I'm having a glass of water and a laser light. Let me show you how total internal reflection happens. Here we see that refraction is happening from the top surface. Okay. Now if I increase the angle of incidence, what will happen? Total internal reflection will happen. Okay. When theta becomes greater than theta critical, angle of incidence. Now if you see, I'm increasing the angle of incidence. Now here, clearly we can see total internal reflection is happening from the top surface as theta is greater than theta critical. So ray optics has so many such interesting phenomena. Hello students, this is your friend Sumit, and today we are going to discuss topic 14 of the series, that is ray optics and optical instruments. This particular topic is having amazing weightage in both mains as well as in advanced. And in this video we are going to learn all the key concepts in great detail along with the type of the questions NTA is asking. With that, I'll provide you the practice sheets also for your practice with the class notes, and you can access that from the link that is given in the description box. When you click the link, you'll join the free batch on the PW app, and as you know, PW app is the most trusted platform trusted by so many top rankers. So let us begin our discussion. We'll be covering the entire chapter, means all the topics in great detail. So few of the important topics I have mentioned here, not all. So we will be discussing reflection, then plane mirrors, spherical mirrors, then refraction, prism, refraction from spherical surfaces, lenses, and the last, that is optical instruments. So we'll be covering everything. Let us begin the discussion with laws of reflection. So we know there are two laws of reflection, and what are them? First is, let us take reflection is happening from a surface. Let us draw a surface. So this is our surface, a ray is coming on this, incident ray. Let us take, this is the incident ray. Okay, this is how we represent the light, as a ray. So this arrow shows the direction. Now if I draw the normal from the surface, let us take a dotted line with a different color. So this is the normal from the surface, and this, no, not the dotted one, the solid one, yeah, and this is the reflected ray. Now the first law states that these three, the ray of incidence, the ray of reflection, and the normal, they lies in the same plane. Okay, so let us take any plane. It may be XY plane, it may be YZ plane, it may be ZX plane, or any other random plane. Okay, so the three, okay, will lie in the same plane. So I will say incident, the reflected, and normal. Same plane. Next thing, the second law is this angle of incidence is equal to angle of reflection. Okay, so these two angles are equal. These are some, you can say these are the basic things that you already know. Now let us talk about the vector law of reflection. Like, we will represent the incident ray as a vector, reflected ray as a vector, and the normal as a vector, and we'll see what is the relation between them. Yeah, this is a bit, you can say, sometimes seems to be a bit difficult to understand, but not that difficult. In mains, a question was asked from this. I'll show you the question. So, and they just asked the formula, the direct formula. Okay, so let us take, this is a plane surface. On this plane surface, again I'm drawing incident ray. This is my incident ray. Okay, now let us draw the reflected first. This is the reflected one. The normal with a different color. This is our normal, not like this. Okay, anyways, this seems fine here. Yeah. Okay. Now let us denote the 3 unit vectors along the directions. So first I am taking the unit vector along the incident ray. Let us represent this as E incidence cap. The unit vector along the reflected, this is E reflected cap. The unit vector along the normal, this is, let us take N cap. Now I'm going to show the relation or write the relation between these two, how we can relate that. One thing we know that if this angle is theta, this angle is also theta. Okay, let us mark the two perpendicular direction. One perpendicular is this N cap, another, let us take this as our horizontal direction, and let us take this direction as some variable. Which one we can take? Let us take P cap, anything, okay. P cap, these two perpendiculars, okay. Now let us resolve E I cap, okay, incidence unit vector. If I resolve E incidence cap, what it is? So this will become my cos theta, and that will become minus N cap, and if I take the sin theta component, that will become P cap. So this will be E I cap, okay, or the magnitude, if I say the magnitude is 1 because this is a unit vector, okay. So this magnitude is 1, so 1 into sin theta P cap. So sin theta P cap, this is the component along P cap, okay. Another along N cap will be this cos of theta, okay. So 1 cos of theta with a negative sign because this is in downward, so minus cos of theta N cap. Okay, this is my incidence unit vector. Now reflected one, ER. Let us write it. Take the component. I am taking a unit vector. Okay, magnitude is 1. So 1 into sin theta P cap, 1 into cos theta N cap. Yeah. Now let us subtract these two. Let us write EI cap minus ER cap. If I subtract these two, so this gets subtracted, this will become 0, this will become minus 2 cos theta minus 2 cos theta N cap. Can I write cos theta in terms of the vectors? Yes, I can write cos theta in terms of the dot product. We know that A dot B is AB cos theta. So if I do this dot, because the angle between these two, EI cap and N cap, how much is that? Between these two vectors, EI cap and N cap is this angle. How much is this? This is 180 minus theta. Okay, so if I write EI cap dot my N cap, so what it will be? Magnitude of A into magnitude of B. Magnitude of both is 1 only. So 1 into cos of angle between them, which is 180 minus theta. So this will become minus cos of theta. Okay, cos 180 minus theta is minus cos theta. Yeah, okay. So this I got minus cos theta, so I can put it here. So this will become E I cap minus E R cap is equals to minus cos theta is this thing. Okay, so this will become 2 into E I cap dot N cap. Outside we have N cap like this. So from here I got my reflected vector is equal to the direction of the reflected, because this is a unit vector. Okay, direction of the reflected vector is coming out to be E incidence minus 2 E incidence dot N cap into N cap. This relation was asked in mains. We derived it quickly. Now do we need to remember it? If you can, it is good. If you cannot, at least understand how I am able to do here. Okay, how I am deriving this. Understand this relation. So if a question comes and you have time in the exam, you can derive it. It will take, I think, 2 minutes, not more than that. Yeah. Now this was the question. Now here we are having A, B and C. They represent the incident, reflected and the normal. Okay. So I am getting that my reflected is equals to E incidence minus. So my reflected is equals to incidence minus twice of incidence dot normal. Okay. Twice of incident dot normal into the normal. D is the correct option here. So if you remember, you can quickly mark. If you don't remember, spend 2 minutes, derive everything, mark it. So generally, what method I would prefer is not remembering. I would prefer deriving it, even if it takes 2 minutes in the exam, because the general things which we remember, I don't prefer remembering many things, but general things we have to remember. Few of the formulas we have to remember. They are must to remember. So we remember them. Most of the questions will be asked from that and we can quickly solve it. If 1%, some questions which are like, let us take this based on this formula, or few things which needed to be derived, if they are asked, I have some spare time at the end. Okay, because I know the things, I can quickly solve the physics paper. Let us take in 45 minutes, I did whatever I could have done. Now 15 minutes is there. I'll spare those 15 minutes in doing things which I don't remember, or there is some need of derivation, or there is need of spending some extra time. So accordingly, everything is managed. Now image of a point object formed by a plane mirror. Let us take a plane mirror. Let us take a plane mirror like this. Let us show the shaded portion of this plane mirror. This is the shaded surface of this plane mirror. Okay, it means if this is shaded, the front one, this one will be the reflected, will be reflecting the light. Okay, this is shaded. Now if we have an object, let us take, we are having an object here where the image will be formed. Take the rays. So one ray, which color should I take? Let us take this color. So one ray I am taking like this. Okay, it's going normal. So when it is going normal, the angle of incidence is 0 degree. So angle of reflection will be 0 degree. It is incidenting like this, it will be reflected back like this. Okay, now another ray, let us take another ray like this. Now here, what is the angle of incidence? This is the normal, this is the angle of incidence. Okay, I. So it will be reflected back at the same angle like this on the other side. So this will be the angle of reflection, which is equal to incidence only. Okay, where these two rays meets, this reflected and this reflected, they don't meet actually, but they will appear to meet. If I extend them, they will appear to meet here. So let us extend them. Which color should I take? Let us take this one. Okay, let us take this one. So if I extend them on the other side, extend this also. Yeah, so they meet here. So they don't actually meet, they appear to meet. So this is not a real image, this is a virtual image. What is the difference between real and virtual? Real image means when the rays actually meet, physically they meet. That is the meaning of real. Okay, physically they meet there, that is the real. When it appears to meet a point, they are not meeting. Okay, here if you see, these rays are not, but they appears to meet here. So this is my virtual image. You got the difference? Another thing we discuss is the erect and the, you can say, inverted image. Okay, so if the object is erect, let us take, if I put the object here, how the image is formed? Here the image is formed like this. So this will be erect. Okay, you can take the image of the head and you will find the image of this tip is coming here. Okay, the image of this foot is coming here. It means the image is erect. So we are getting erect and virtual, and the size is the same. This distance, if you take, let us take some distance x, so this distance is also x. Why so? Because this angle is same, this angle is same. Okay, so this is same, this height is same, and these two right angle triangles, these angles are same. It means this distance and this distance has to be same. So if an image is there, if a plane mirror is there, the image will be formed at the same distance on the other side of the mirror. That point is clear. Okay, now let us do some question on this. An object is placed at a distance 12 centimeter in front of a plane mirror. The virtual and erect image is formed. You see, this is a virtual and erect, yes. Virtual and erect image is formed by the mirror. Now, the mirror is moved by 4 centimeter towards the stationary object. Now, towards the stationary object, the distance by which the position of image would be shifted. Let us show how everything works here. Okay, what was the thing? Object is placed at 12 centimeter. So let us say this is my mirror. Okay, object is placed here and this distance is 12 centimeter. Where the image will be formed? On the other side. So here the image will be, and this distance will be 12 centimeter. Now what we did? The mirror is moved by 4 centimeter towards the stationary object. Now the object is kept stationary and we moved the mirror towards the object. Here, how much we moved? 4 centimeters. So how much is the remaining distance? This 8 centimeters. Where the image will be formed? Here. At what distance from this? 8 centimeter. Initially, the image was at a distance of how much from the object? 12 plus 12, 24. Now, the image is at a distance of 8 plus 8, 16 centimeter. How much the image moved? This distance. How much is that? 24 minus 16. That is 8 centimeter. So, the image moved 8 centimeter towards the mirror. Yes, the image moved 8 centimeter towards the mirror. Very simple question. Very easy question. And this was asked in 2023. Now, let us discuss about the minimum size of the mirror that is required for a person to see the complete image. Let us take a person is standing in front of a mirror. Now, how much is the minimum height of the mirror is required so that he can completely see himself? Draw a mirror. Let us take this as a mirror. It is shaded here. Okay, a person is standing in front of the mirror. Here we can show. Okay, let us connect this like this. Okay, the person is standing here. Now, if he has to completely see himself in the mirror, he should be able to see his head, or you can say his eyes. Okay, and he should be able to see, or she should be able to see the feet. Now, to see the eyes or the head, how the rays will go? The rays will go like this, reflect from the mirror. The ray will go like this, reflect from the mirror, okay, and they'll come back. Now he is able to see the eyes, or you can say the top, the head. Now he want to see the feet. How? The rays will go like this, reflect here and reach the eyes like this, isn't it? Yes. Now law of reflection tells that this angle is theta, so this is also theta, isn't it? So if total height is h How much is this height? H by 2, because both the angles are theta. So this is H by 2. I need only this portion of mirror. I don't need this proportion of the mirror. Okay, so minimum height of the mirror to see this, to see himself is H by 2. Half of the height of the person, not equal to the height of the person. This is half of the height of the person. Isn't it interesting? Yes. Now, angle of deviation. A ray incidence on a plane surface, plane mirror I am taking. Let me use green color only because I am using that for mirror. So, let us take this as plane mirror and a ray is incident on it at an angle theta. At an angle theta like this. It will get reflected? Yes. At what angle? Same angle. Let us draw the normal here. Which color I can use? Let us take white color this time. So this is normal. Okay. And this is the reflected ray. Okay. Now, how much is the deviation in this ray? If I ask you how much the ray deviated. Now, what was the original path of the ray? The ray originally was moving along this direction. And it deviated, and finally, due to reflection, it is moving along that. So, this angle is the angle of deviation. This is angle of incidence I. This is angle of reflection, which is equal to angle of incidence. So I can say R, this is equals to I. So if I ask you how much is this angle, this total is 180. So this will be 180 minus 2I. This is the total deviation by this ray. So if a plane mirror is there, a ray comes, somebody asks you how much is the total deviation, you will say 180 minus 2I. Or if angle of incidence sometimes we represent as theta, so you can say 180 pi minus 2 theta or 180 minus 2 theta. Okay. Now, if let us take, we have two plane mirrors, they are inclined at a particular angle theta with each other. Now, if I ask you how much is the total deviation, this was for single mirror. Now, if I ask you for two plane mirrors, okay, let us take, we are having two plane mirrors. Let us draw them. They are inclined at an angle theta with each other, not a dotted one, solid line. So this is one plane mirror, this is another plane mirror. Okay. A ray is incident like this. Okay, or different color I should take, I think this. So a ray is incident like this here at some angle with the normal. Let us draw the normal here. So this is the normal here. This angle is angle of incidence. Let us take I. And here I am considering the two plane mirrors are at an angle theta with each other. Take one reflection from each mirror and then tell how much will be the total deviation in the path of the ray. How much is the total deviation? Okay. Now, if you want to do, you can pause this video and try to draw the ray diagram and then see how much is the total deviation. Then you come back. Okay. So take a pause, then come back. Then I'll continue further from here. Okay. I hope you are back. So after reflection from here, it will go like this. Like this. Okay. This angle is also I. Draw a normal on that surface. So here this is my normal start like this. This is my normal. Okay, now there the ray will again get reflected and it will go somewhat like this. Okay, it's not exactly horizontal. Let me show it again. Somewhat like this. Okay. This angle is I, and now one thing, this was the original direction of the ray. Okay, now first it deviated here, then again it deviated here, and finally it is moving in this direction. So if I ask you how much is the deviation, so you take the total deviation. Okay, first deviation like this, then deviation like this, so that is this total angle. This is my deviation here. So that we need to find. Now two ways, either you separately take first the deviation from here, then deviation from this surface, and then sum up the individual one, or what you can do is you can try to find how much is this angle. Let us do that. So this is I, how much is this? This is 90 minus I. How much is this angle if I ask you? So the three sum is, this is 90 minus I. Sum of these three angles is 180. So if I ask you how much is this angle, you will say this is 180 minus this plus this. So this is theta plus 90 minus I. So how much it is now? 180 minus 90, when it happen, it will become 90 here. So 90 minus of theta minus minus plus, so plus I. How much will be this angle? This total is 90. So 90 minus this, 90 minus this. So what it will become? So 90 minus of this, if you do, it will become theta minus I. So this comes out to be theta minus I. If this is theta minus I, this angle is also theta minus I. Yes. I got this angle, I got this angle, this is I, this is I. I ask you how much is this angle? How much is that angle? So in this triangle you will say the sum of this plus this is 180. So 180 minus these two. So 180 minus, how much is this total? This total is 2i. So 2i. Okay, and how much is this total? So this is 2 theta minus 2i. So plus 2 theta minus 2i. How much it became? So this is 180 minus 2 theta. So this is 180 minus 2 theta, this angle. Okay, let us take a highlighter. Okay, I'm talking about this. You see, this angle is 180 minus 2 theta. What I did in this triangle, I did sum of the three angles to be 360. Okay, sorry, not 360, 180. So 180 minus these two, so that becomes 180 minus 2 theta. So this angle becomes 180 minus 2 theta. Now from there, if I ask you how much is this angle total, this total deviation, so you will say this is 180 plus this. So total deviation will become 180 plus 180 minus 2 theta. So this becomes 2 pi minus 2 theta or 360 minus 2 theta. So I remember it like this, 2 pi minus 2 theta. Okay, you could have done separately also. First take deviation from this. What that will be 180 minus 2 theta, then 2 of I. Okay, then write the deviation from this. So there the angle is theta minus I. So again you can write, let me show you. First deviation from here, what it will be? 180 minus 2i. Okay, plus deviation from this, what it will be? 180 minus 2 into angle of incidence here is theta minus I. So theta minus I. Now you do. So this will become 180 minus 2i plus 180 minus 2 theta plus 2i. You see this 2i is getting cancelled. So this is 2 pi minus 2 theta. Same thing. Okay. Now one thing that is needed to be considered from here is I took single reflection from both the mirrors, not multiple reflections. If these mirrors are extending till, let us take, infinity or large distance, then there will be multiple reflection. This is deviation only after one reflection from each mirror. That's all. Let us discuss this question. This was asked in 2022. Here we are having two plane mirrors inclined at an angle 75 degree with each other, and now it is asked, after reflecting from mirrors, M1 is it get reflected back to the mirror M2, okay, with an angle of reflection 30 degree. The total deviation of the ray will be, how much is that? 2 pi minus 2 theta. So 360 minus 2 into angle between the plane mirrors, 75. So 360 minus 150, that is 210 degree. Now one thing to note here is, this is independent of the angle of incidence, isn't it? Here the angle of incidence I considered I, the deviation is independent of angle of incidence. In case of the single mirror, it was depending upon the angle of incidence, not in case of the two mirrors. Getting it? Yeah. So although here you may say angle is given, that is not needed. This 30 degree is not needed for us. We just need the angle between the two plane mirrors. That's all. Okay. Rotation of mirror. Now, if a plane mirror is there, like this surface is our silvered, and let us show the incident ray like this. Then the reflected ray will be like this. Draw the normal here. This is our normal. Okay. This is our normal. Here we see this is the angle of incidence I, and angle of reflection here. Okay, let me name them both as theta. Okay, I'm just writing as theta. So this is theta, this is also theta. Now what will happen if I rotate this plane mirror by an angle theta? How much angle will be rotated by the reflected ray? If I ask you, I am rotating the plane mirror by an angle theta. Tell me in the comments. Take a pause, try to draw the ray diagram, then see how much, if I rotate this plane mirror by theta, how much angle will be rotated by this reflected ray. Take a pause, draw the ray diagram, put in the comments with the timeline, then come back. Okay, I hope you are back. Now, if I rotate this plane mirror, let us rotate it. I rotated it like this. Okay, and this angle is theta, not theta. Let us take some different angle, alpha. Okay, this angle is alpha. Now, angle of incidence, the normal will rotate. Yeah, normal will rotate. The normal will be like this. By how much angle the normal will rotate? Alpha only, isn't it? The perpendicular to plane mirror will rotate by alpha. Yes. So this is alpha. So how much will be the angle of incidence? The angle of incidence will be this angle. How much is that? Theta minus alpha now. Theta minus alpha. Now the reflected ray, let me show with a different color in this case. Yeah. So the reflected ray will be at same angle like this, theta minus alpha, with this normal. This is theta minus alpha. Now how much is this angle? This is 2 alpha, isn't it? This is theta minus alpha, this is theta minus alpha. This total was 2 theta, so remaining is 2 alpha, that is this angle. So my reflected ray rotated by 2 alpha, not by alpha, by 2 alpha. The plane mirror rotated by alpha, the reflected ray rotated by 2 alpha. Make it a point. Now, number of images formulas, you might have seen these formulas. So, for two plane mirrors, okay. So, when two plane mirrors are inclined at an angle theta, and if you put an object in between, how many number of images will be formed? First, if that is a even, if you divide 360 by theta, okay, if 360 by theta is an even integer, okay, so if 360 by theta is an even integer, number of images is 360 by theta minus 1. Second, if 360 by theta is an odd integer, now for odd integer there are two cases. First is you are putting the object at the angle bisector. Second, you are not putting the object as angle bisector. So for symmetric case, when the object is at angle bisector, the number of images is 360 by theta minus 1. For the other case, it is 360 by theta. Do we need to remember this? No, don't remember, just understand thing. Let us do a question here. Two plane mirrors M1 and M2 are at right angles to each other as shown. Point P is placed at a distance A and 2a meter away from M1 and M2 respectively. The largest distance between the images thus formed is. Now, how many images will be formed? First of all, from this plane mirror, I'll say that this is my first image that will be formed here. At what distance? At A only. Due to this plane mirror, my image will be formed here. Okay, and how much is that distance? This is 2a, this is also 2a. This here space is less, so this is my 2a here. Okay, now second, you take the second reflection. Now this image will act as an object for this and take the second reflection. So second, you can say this is my A, so this image will be formed here. And at what distance? This is A, so this is also A. So this will be at a distance 2A like this and 2A here. If you take the reflection of this from this, it will overlap here. So total here 3 images are forming. Now it is asking the largest distance between the images. Now if I tell you the distance between these two images, how much is that? 2a, that is 4a. Okay, yeah. If I ask you how much is the distance between these two images, that is 2a. So I am getting 2a, I am getting 4a, and how much is the distance between these two images? Means this distance I am talking about. This is 4a, this is 2a. So if I write this distance, so that will be root of 4a square plus 2a square. You can take 2a square out. Okay, so if you take that out of the root, it will just become 2a. Inside the root, it will become 2 square plus 1, that is root 5. So 2 root 5a, root 5 is 2.3, 2.3 into 2 is 4.6a. So I'm getting another one, that is 4.6a. So the larger distance is 4.6a, which is option C. Okay, simple. Yes. Now let us talk about the velocity of the image, and I'm talking here for plane mirror. Okay. For plane mirror case. Now consider a plane mirror. Let us take, this is my plane mirror. I'm drawing it again here because I'll show the two velocities separately. One the perpendicular to the plane mirror, another parallel to the plane mirror. Now let us take, my object is moving in first case perpendicular to the plane mirror. Let us take in this direction with some velocity v. Now the image is always at the same distance on the other side. If this distance is x, this distance is x, always. So if this is moving with velocity v, this image will also move with velocity v. So if I say this is my v perpendicular Okay, so what is this? Magnitude is v perpendicular only, but with a negative sign. So if this is v perpendicular, so this is minus v perpendicular vector. Minus v perpendicular vector. Now let us talk about the parallel component. Let us take the object is here and it is having some velocity along the plane mirror, and let us take this is my v parallel. What will be the velocity of the image? The image will be moving parallelly, because if the object is here, the image is here. If the object is here, the image will be here. So image is moving with the same velocity in this direction. So this velocity will be v parallel only. Okay. Is that point clear? Okay. So if I say my velocity of object is v perpendicular, okay, and let us take this as one direction, okay, you may say I cap or j cap, like that. V perpendicular I cap plus v parallel j cap. Okay, I'm taking here this as my I cap, this as my j cap. So the velocity of image will be, the perpendicular component becomes opposite, the parallel component will remain the same. Just understand, don't try to memorize this. Just try to understand that the perpendicular component is getting opposite, the parallel component will remain the same. Now coming to the next topic, that is spherical mirrors. Spherical mirrors means my mirror is in a spherical shape. Okay, so it is a part of a, you can say, sphere. Let us say this is a sphere and the mirror is some portion of the sphere. Now for mirrors, one side has to be silvered. If I silver the outer part, okay, the inner one will be the reflecting one. If the inner is reflecting, I say the name of the mirror is concave mirror. If I silver the inner part, the outer one will be reflecting, and that I say the convex mirror. So in concave mirror, the inner part, inner curved part is reflecting. In convex mirror, the outer curved part is reflecting. Got it? Now this is a part of sphere. Certainly there will be some center of the sphere. This is my C. Okay. Here this is my C. Center, we call this as center of curvature of the mirror. Now let us talk about the ray diagrams. I'm taking one as my concave mirror, another as the convex mirror. Okay. This is the principal axis. Here also, this is the principal axis passing through the center. Okay. This point in contact with the mirror, we call that as my pole. Okay. The center of this sphere is my center of curvature C. Here my center of curvature C. Okay. And if a parallel ray comes parallel to the principal axis, it passes through the focus and and this we call as f, the focus. This length is the focal length of the mirror. Okay, this is my r, the radius of curvature. So here we know that f is equal to r by 2. How this relation comes? So let us take the incidence is coming here. Okay, this is parallel to the principal axis, and let us draw a normal there. So how to draw a normal on a point on the sphere? Just connect that to the center. Okay, so just connect this to the center. Connect this to the center means this becomes the normal there. So what is the angle of incidence? This is the angle of incidence. This is I. If this is I, this angle is also I. Yes. And this is also I. Law of reflection, angle of incidence is equals to angle of reflection. If this is I can say this is my twice of I. Yes, this is I. This total is 2I. So this is also 2I, isn't it? So now you see, I'm talking about, I made here this, let me take different color. I made here this perpendicular, okay, like this. Now, let me say this is point A, okay, let us take this as point B. If I say 10I, I'm talking about which right angle triangle? Let me highlight for you. So I'm talking about this right angle triangle here. This right angle triangle I'm talking about. So if I say 10I in this case, what it will be? 10I will be AB divided by CB. Okay. Now similarly, if I talk about 10I in this right angle triangle, which one? Now see carefully, this right angle triangle. Now here I'll say that 10 of 2I is equal to AB divided by FB. Now I'm taking this ray to be near to the principal axis. These angles are small, so tan theta is nearly equal to theta. So tan I is nearly equals to I. This is 2I. So I'll say AB by FB is equal to twice of AB by CB. AB got cancelled here, and I can say that my FB comes out to be CB by 2. What is FB? FB is this distance. Now focal length was from pole to here. I am neglecting this BP. Why? So I took the ray very near to the principal axis. So this BP is very, very small. So here FB comes out to be my focal length and my CB by 2. CB is my radius of curvature. So this becomes R by 2. Small derivation. Okay. So F is equal to R by. Anyways, you know this thing. So same thing there also. Now, okay, we discussed about center of curvature, about pole, about focal length, radius of curvature. Okay. Now, if a ray is coming parallel to the principal axis, it will pass through the focus. Now, same here, if a ray comes parallel to the principal axis in this case, can it pass through the focus? No. But it will appear to pass through the focus. So this is my focus and this ray will appear to pass through the focus. This is my reflected ray here. Okay. This is my reflected ray. And if I extend this on the other side, it will appear to pass through the focus. I drew a normal here. Like this. This is angle of incidence. This is angle of reflection, which both are equal. Okay. Now another thing, if a ray pass through C, what will happen? It will just follow, you can say, retrace its path. So let us take the two things, two mirrors again quickly. Will not invest so much time in this because you already know these things from 9th and 10th class. Different color I need to take. Let us take yellow. Okay, so this is my C, this is my focus, this is pole. Okay, if you take a ray which passes through C, okay, now after reflection it will retrace its path. Why so? Because angle of incidence is 0 degree. You draw a normal is along the angle of this my incident ray. Okay, so the angle of incidence is 0, angle of reflection is 0, so the ray will retrace its path. Same thing will happen on the convex mirror case. This is my convex mirror. This is F, this is C here. A ray is incident along C like this. Okay, so if you extend it, it will appear like it is passing through C, and after reflection it will retrace its path like this. Okay, and the third thing, if you take a ray passing, I'm drawing it separately so that you understand nicely. Okay, so this is, let us take, this is my focus, this is my center of curvature. If you consider a ray incident, okay, which passes through focus, what will happen? Just the opposite. After reflection, it will go parallel to the principal axis. After reflection, it will go parallel to the principal axis. Okay, I didn't do this line. It will go like this. What is the assumption here? Here this ray is going near, you can say, near to the principal axis. Yes. Okay, same thing on the other side also. If you take the mirror inner part is shaded. I'm trying to be quick in drawing these ray diagrams. Okay, this is my focus, this is my center of curvature. A ray is passing through the focus, certainly cannot pass, so it will appear it like it is passing through the focus, appear like that. So if you extend it, it will pass through the focus. So after reflection, it will go like this, parallel to the principal axis. Okay, another, if the ray is directly incident on the pole, oh, different color. You know these things, but still I am telling you again just for your revision. So a ray is incident like this, the reflected will go like this at the same angle. If this angle is theta, this is also theta. Let us take for the convex mirror also quickly. Oh, different color. Okay, take a ray like this, it will go like this. This angle is theta, this is also theta. Okay, Now homework for you. Draw all the standard ray diagrams for the convex and the concave mirror when the object is at infinity, when the object is between C and F, when the object is at C, when the object is at F, when the object is between F and P, all those ray diagrams. Okay, so this is homework for you. Draw all standard ray diagrams for my object and image for convex and concave mirror. Okay, and these you have studied in your 10th standard, so it is very easy for you. Now let us talk about the mirror formula. Let us try to relate the image and the object distance with the focal length. So consider a mirror, spherical mirror. I am taking a concave mirror like this. Draw the principal axis. This is the principal axis. Okay. Now let us take object. I'm taking my object to be somewhat here. Let's take a different color. So this is my object. Okay. Now consider the two rays from here. One I can take, it is just normal. Okay, so it will go like this, will be reflected back along the same path. Another ray I can take, let us take another ray which is, how should I take? Okay, I am considering here that this is my center of curvature, this is my focus here, and yeah, so another ray I am taking, let me take this, yeah, so another ray I am taking to be somewhat like this. Okay, let us draw normal here. So this white color, this is the normal. Yeah, so it will be reflected. How it will be reflected? It is going like this, so it will be reflected like this. With a different color, it will be reflected like this. Okay, extending it. It was going like this, now it is reflected here, and my final image will be at the intersection of the two rays. The another ray was coming like this. Okay, so the final image is at the intersection of the two rays, and this is my image. This was my object. I took it like this. Now let us try to relate the image and the object distances. So first of all, let us name the angles. So I'm considering this angle to be my alpha. Okay, let us take this angle is alpha, and this angle is my beta, and this angle as my gamma. Okay, this is angle of incidence. You may consider that as I or theta. So this is my theta. Angle of incidence was this here, theta, and this is angle of reflection, which is also theta. These two are theta, theta. Okay, angle of incidence and angle of reflection both are theta, theta. Now I'm one by one, I'll take some triangles in this. I'll highlight those triangles. So in this triangle, if I talk about, the external angle is beta, internals are alpha and theta. So I'll say alpha plus theta is my beta. So beta is equals to alpha plus theta. Similarly, take another triangle. Okay, this was a bit bigger. Let me make it a bit smaller here. And now consider this triangle. This triangle I'm talking about. So in this triangle, gamma is my external. So I'll say gamma is equals to beta plus theta. Gamma is equals to beta plus theta. Okay, now from here eliminate theta. So from the upper one, I can say my theta is equals to beta minus alpha. Let us put here. So gamma is equals to beta plus theta is beta minus alpha. So I got my gamma is equals to 2 beta minus alpha. Now I'm taking these angles to be very, very small. Okay, so gamma I can say as my 10 gamma, beta I can say as my 10 beta, and alpha I can say as my 10 alpha. Now 10 gamma, right? 10 gamma. So I'm taking this point as my M, this point as my P. Okay, so this pole is somewhat here only. Okay, everything is very near to the principal axis. So which angle? 10 gamma. 10 gamma is my MP divided by OP. MP by OP. Is equal to 2. 10 beta is MP divided by CP. MP divided by CP. Minus 10 alpha. 10 alpha is MP divided by IP. MP is common everywhere. So this is 1 by OP is equal to 2 by CP minus 1 by IP. Now let us take sign convention. Now we will define one method of sign convention, and we will follow that in case of lenses also, mirrors also, and in case of reflection from spherical surface also, everywhere. So we define one sign convention. What is that sign convention? All the distances along the principal axis will be measured from the pole. Okay, now you will start measuring from the pole. Any distance which you measure in direction with the incident ray are positive, and in the direction opposite to the incident ray are negative. Now incident ray is coming like this. If you take any direction opposite, if you move like this, your distance will be negative. Okay, so this I am talking about along the principal axis. Okay, so in direction of my incoming ray or incident ray as positive, and in opposite direction as negative. Okay, so this was for along the distance along the principal axis. Another one perpendicular to the principal axis. So if you take the distances upward, that are positive, downward negative. That's all. Need not write everything. Okay, so OP, this distance I need to take. All the distance has to be considered from pole. So that is this distance. I'm measuring in this direction. In this direction means negative, and this is the distance of my object that I denote with U. So I'll write this as minus U. OP is minus U. Next is 2 by CP. CP is R, and this that will measured in this direction opposite, so minus R. Minus 1 by IP. IP is Okay, this distance that will measure in opposite direction. Okay, so a negative sign there again, and this I say the distance of image. So u is the distance of object and v is the distance of image. Okay, this is distance. Okay, so what I got, r by 2 is my focal length, so I'll say here that this will become 1 by v, okay, plus 1 by u I'll take on the other side, 2 by r I'll take on left side, so everything will become positive everywhere. So this will become 1 by v plus 1 by u is equals to 1 by f. 1 by v plus 1 by u is equals to 1 by f, and this becomes my mirror formula, spherical mirror formula. Okay, very important. Why I did derivation here, that was not needed. I did such that you understand the concepts in a more better way, although I could have written this formula directly. Okay, now from here if you see, the focal length of the concave mirror is positive, the focal length of the convex mirror, focal length of concave mirror is negative, and of the convex mirror is positive because I am moving in the direction. Okay, so my concave mirror is having positive focal length according to sign convention I am saying, okay, and my convex, not positive, no, negative focal length, and my convex mirror is having positive focal length. Now in lens also we will discuss these things. So try to memorize one thing. If it is convex, positive, whether it is mirror or whether it is lens. If convex is there, convex mirror, convex lens has positive focal length. Concave mirror, concave lens has negative focal length. Okay. Next is magnification. How magnification is defined? So magnification is defined as height of image divided by height of object. And quickly we can do the derivation for this also. Let us try to be a bit quick. Because I don't want to make this one shot to be very lengthy. I want everything to be revised very quickly. Okay, so therefore showing you the derivations quickly. So you can take an object here. Okay, let us take, this is my C, this is my F. I took an object somewhat here. Draw the ray diagram for this. So from the top I'm taking this to be parallel to the principal axis, so this ray will pass through the focus like this. This ray will pass like this. Okay, another ray I can take like this. So this ray will pass like this. So my image is here and this is the height of image. Let us take this as AB. So you will say this as A dash, B dash. If I say this angle as theta, so this angle is also theta. So if I write tan theta in the upper triangle, tan theta is equals to AB divided by, let us take this as my pole P, so divided by BP. And this is same as this tan theta, so this is my A dash B dash, A dash B dash divided by the base here, that is B dash P, that is B dash P. Yeah. Okay, now put the sign conventions. AB is my plus H divided by BP. This is the distance of the object, so negative of U is equals to A dash B dash. I'm measuring it on the downward side, so minus of H dash or H image. Okay, minus of H image divided by B dash P P. B dash P is the distance of the image I'm measuring from here. So negative sign is there, minus of V. So from here I got my H image divided by H object. This was H object. What is that? This is coming out to be minus V by U. So minus V by U. This becomes the formula for magnification. Make sure you remember it. Okay, make sure you remember it. Keep this thing in mind. Okay, in case of lengths, we'll have plus V by U. Now let us talk about some type of questions that are asked in mains. So this is asked in 2024. A convex mirror of radius of curvature 30 centimeter forms an image that is half the size of object. The object distance is. So this is convex mirror. Convex mirror will always form image for real object I'm talking about behind the mirror. Okay, the image will be erect in nature, you know that. So the magnification will be positive. So the magnification is positive. So magnification is plus 1 by 2 because it is mentioned that half the size of the object. Now two options was there, either minus 1 by 2 or plus 1 by 2. Because this was convex mirror, therefore I told that it is plus 1 by 2. Okay, radius of curvature is 30, so I got my focal length to be 15 centimeter. The object distance is. Now what is the distance of the object? Means I need what is U. Okay, so I can write this as my minus V by U. From here I got my V as minus U by 2. V as minus U by 2. Now use the formula 1 by V plus 1 by U is equals to 1 by F. What is V? V is minus U by 2. So minus of 2 by U plus 1 by U is equals to 1 by F. Okay. So from here everything is fine. Yeah. Everything is fine. Okay. So from here this is minus 1 by U is equals to 1 by F. From here I got my U to be minus F. F is 15, so minus 15 centimeter. In the options, you see the sign convention is followed. Okay. Another question. A thin cylindrical rod of length 10 centimeter is placed horizontally on the principal axis of concave mirror of focal length 20 centimeter. The rod is placed in such a way that the midpoint of the rod is at 40 centimeter. Okay, let us draw the diagram first. You'll understand in a better way. So this is my concave mirror. Okay, now principal axis is not like this. This is my principal axis. Okay, and what is mentioned, let us take this is my focus, this is my center of curvature. The cylindrical rod is of length 10 centimeter and it is placed horizontally on the principal axis of concave mirror of focal length 20. So this is 20 and this total is 40 from here. Okay. The rod is placed in such a way that midpoint of rod is at 40 centimeter from the pole. So rod midpoint is lying at C. Rod midpoint is lying at C. So the rod is which color? Let us take this. So rod is somewhat like this. Okay, it's a bit shorter one. Let us take it like this. Okay. The rod is like this. Let me do it again. So the rod is from here to here. Okay, now mark the 2 points of the rod, 2 ends of the rod. So this is one end. What is the distance of this end? This is 40. Total length is 10 for rod. So this is 5. So this distance is 45. Another, this end 40 minus 5, so 35. So this end is at 35 centimeter. Now just use the mirror formula and take the point the u to be minus 45, in the second case minus 35, and then try to solve for v1 and v2. You'll get the images of the two ends of the rod. From there you'll get what is the length of the image. Yeah, the length of the image. Yeah, so use the formula 1 by v plus 1 by u is equals to 1 by f. So I'm talking about, let us take, this is my 1 and this is my 2. Now for 1, if I talk about, so 1 by v1, u is minus 45, so minus 1 by 45 is equals to 1 by f. What is f? Focal length is 20, and with a negative sign because this is a concave mirror, so this becomes 1 by v1 equal to 1 by 45 minus 1 by 20. So my v1 comes out to be 45 into 20 divided by 45 minus 20, that is 25, and a negative sign is there. If I write my v2, instead of 45 I'll take 35, so this will become minus 35 into 20 divided by 35 minus 20. Okay, and then you need to take the distance, so just take the separation between v1 and v2. So what is v1 minus v2? That is my length of the rod, and just mark the answer. So do the calculations, take the pause, solve this, and mention your answer with the timeline. Take a pause, do it. Okay, I hope you are done. Now, velocity of image. In case of mirrors, plane mirrors, we discussed how to write the velocity of image. Now we are talking about the spherical mirrors. So here also we'll have two components, one along the principal axis. Okay, so let us write here along, principal axis, along the principal axis. Okay, and another case I'll take perpendicular to principal axis, perpendicular to principal axis. So now consider object is moving like this with some velocity. Okay, some velocity of object along the so you can write this as let us take v parallel. Okay, anything, doesn't matter. So I'm talking about this. Now here my distance u is changing with some rate. What is the rate? You can write here the rate as with the velocity with which it is moving. Okay, so my object, my distance of the image, that is my v will be changing. How it will be changing? We can relate with the formula 1 by v plus 1 by u is equal to 1 by f. Here my u and v are changing, focal length of the mirror is constant, that is not changing, so differentiate it with respect to time. So what it will become, minus 1 by v square into dv by dt minus 1 by u square into du by dt. Are you able to visualize separately v and u? So this is my u, okay, into du by dt, and here focal length is constant, therefore that differentiation is 0. So from here I can say dv by dt is coming out to be v square by u square with a negative sign into du by dt. And so I can say my velocity of image is minus of m square. Now v by u, minus v by u is my m, minus v by u square, that will become v square by u square only, so this will become minus m square. So minus m square into velocity of object. This was for the case, which case? Along the principal axis. Oh, I took a box. Okay. Now perpendicular to the principal axis, that is much easy. This is much easy. Okay. So let us take here the velocity is like this, or you may say the object is maybe somewhat here and it is moving like this, perpendicular to the principal axis. So image will be somewhere. This is at this point. I'll say this is my height of this point from the principal axis. How the height of the image of this point will be related with the magnification. So I'll say height of my object divide height of image divided by height of object. This is related as minus v by u. Yes. So height of image is, or in terms of magnification, if I write as m times of height of object. Differentiate this. So dh image by dt is equals to m times of dh object by dt. So this becomes the velocity of image is equals to magnification times the velocity of object. Okay, magnification times the velocity of object, that's all. Here this was my okay, getting it? Everything is fine? Great. Now one important thing here to consider. When I am saying this velocity along the principal axis, velocity perpendicular to the principal axis, here I am taking distances from the mirror. So these velocities are with respect to the mirror. Okay, these velocities are with respect to the mirror. So this velocity is velocity of image with respect to the mirror. Getting it? Here I should write separately. Let me write here with the green color. Okay, so these velocities are with respect to the mirror, because I am taking the distances with respect to the mirror. I am taking distances not with respect to the ground. I am not taking with respect to ground, I am taking with respect to the mirror. Therefore, these are velocities with respect to the mirror. Okay, this was the important point. Now, coming to the questions. Let us do this question. What it is asking. Car B overtakes another car A at a relative speed of 40 meters per second. How fast will the image of car B appear to move in the mirror of focal length 10 cm fitted in car A when car B is 1.9 meter away from car A? Now, what is the speed of the object? 40 meters per second. Okay, this is relative speed. So, with respect to mirror, so this is the mirror of car A. Which mirror it is? Convex mirror. Okay, so this is my mirror of car A. My car B is coming like this with velocity 40 meters per second. The focal length is 10 centimeter. Car B is 1.9 meter away at this instant. Okay, now what you need to do? This velocity is along the principal axis. Find the magnification, write the velocity of the image. Okay, and then you can mark the answer. Okay, let us solve it. So first of all, I'll write 1 by V plus 1 by U is equals to 1 by F. Now 1 by V U is 190 meters, so 1.9 meters, so it will be 190 centimeter. Okay, so minus of 190 centimeter is equals to 1 by f. What is f? F is 10 and focal length is plus for convex, so plus 1 by 10. So from here 1 by v is coming out to be 1 by 190 plus 1 by 10. So what it is now? 190 I'll take as LCM. So this will become 1 plus and here 19. So this is 20 by 190. From here, if I write the magnification, that is my minus V by U. How much is that? Minus of, what is V? V is 190 by 20. 190 by 20 means 19 by 2. What is U? U is 190 centimeter with a negative sign. So this is 1 by 20. Okay. Now velocity of image if I write, so that is minus m square into velocity of object. See this formula again. This formula. Highlight this with a different color. This formula. Okay, and yeah, so put it, velocity of image is equals to minus of 1 by 20 square into velocity of object is 40 meter per second. So you can write this velocity is 40 I cap. Okay, so this is my, okay, anyways, direction is not asking. So what it will become? So this will become 40 divided by, just he needs the magnitude, not the direction. So it will become 40 divided by 400. So this is 1 by 10, 1 by 10, which is 0.1 meter per second. You just need the magnitude. Okay, getting it? This question was asked in 2021. So this you can say from general question, this is a bit difficult because generally the velocity case many of the students are not able to understand, but if they understand, they remember the formula, they can solve the questions very quickly. Because here what he can ask, there is nothing more to ask. What he can ask? Maximum, the direction, that's all. The magnitude, the direction, that's all. Okay, so nothing more to ask. According to mains level I am talking about. So if some question comes, it will be very easy, formula based only. Now refraction of light. As we know that when a light travels from one medium to another medium, what happens? What will change? The speed of the light change. The speed of the light will change. In vacuum, the speed of light is 3 into 10 to the power 8. In different medium, the speed of light will be a bit less. Certainly, in vacuum it is maximum. So in other medium, the speed of the light will be somewhat different. The frequency of the light remains same. Frequency will remain same. Frequency will not change. The wavelength will change because a speed of light is frequency into the wavelength. Whole is constant. Frequency remains constant. Wavelength changes. And the light bends with the normal. Okay, like if it is going from rarer to denser, the light will bend along the normal. If it is going from denser to rarer, it will bend away from the normal. Okay, as you have felt, like if you put a pencil or a pen inside a glass, let us take you can take a glass cup. Okay, a cup made of glass. Okay, put water in it and then you put a pen. So what you will see? You will see the pen is bent a bit. Why so? Due to the refraction phenomena. So when a light goes from one medium to another medium, not a dotted one, solid. So let us take, this is my medium 1. And this is medium 2. So if a light is going from one medium to another medium, let us take, the ray was coming like this at some angle with the normal, and after refraction, okay, this color, after refraction it goes like this. Here I say this angle as my angle of incidence, this angle as the angle of refraction R. Okay, here this is medium 1, this is my medium 2. So you see here the angle with the normal is not the same. As the medium changes, the light bends. Here it is bending towards the normal, so I can say my medium 2 is denser. If it bends away from the normal, I'll say medium 2 is my rarer medium. Okay, now let us define the refractive index of the mediums. So refractive index of a medium is defined as the speed of light in the vacuum divided by the speed of light in that particular medium. So speed of light in vacuum divided by the speed of light in that particular medium. C we denote default for speed of light in vacuum. So C by V. Okay, this we call as the refractive index of a medium. Now refractive index of a medium is always greater than 1. Why so? Because speed of light in any medium will be less than the speed of light in vacuum. Yeah. So what is the unit of this refractive index? It is unitless. Both are speeds, therefore it is unitless. Let us take here the refractive index is N1. For this medium, the refractive index is N2. So Snell's law says that the N1 into sine of angle incidence is equal to N2 into sine of angle of refraction. Or I can write it like this also, that sine I by sine R, this is equal to N2 by N1, and we can write this as N21. Also N21 means refractive index of medium 2 with respect to medium 1. And if you write this in terms of speed of light, N2 is what you will write N2? N2 you will write as C by V2 and N1 as C by V1. So this becomes my V1 by V2 in terms of the speeds of light in medium 1 and medium 2. Okay. So this is my Snell's law. And the thing that these three, the incident ray, the normal and the refracted ray, they are in the same plane. So that will be followed here. And the relation between angle of incidence and angle of refraction is given by Snell's law, that is this. And this is how we relate that with the refractive index, where N21 denotes the refractive index of medium 2 with respect to medium 1. Now if let us take the light is passing through multiple layers. Okay, let us say this is you can say medium 1, this is medium 2, and then further also there are different medium. Let us take here. After this, let us take it is medium 3. Okay, and this ray is coming like this till here, coming like this till here. Again it will be refracted. This is the normal. It may bend towards or away depending upon the refractive index. Okay, this is R, this angle will be R only. I am taking these to be parallel like this. Let us take this angle to be anything angle. You may take this to be R2. Let us take this as R1. Okay, this is my R2. So again you will say here mu1 N1 into sine I is equals to N2 into sine R is equals to my N3 into sine R3 or R2, anything. You may take this to be R3. So I'll say N1 sine I is equals to N2 sine R is equals to N3 sine R3. and it will continue. There are different medii. Okay, so similarly you can write it like this: n4 sin r4 is equals to n5 sin r5, like that. You can continue. Okay, now coming to question. Consider a light ray traveling in air is incident into a medium of refractive index root 2n. The angle of incidence is twice the angle of refracting. Okay, the angle of incidence will be. Now what is mentioned? Angle of incidence is equals to twice the angle of refraction. From here I got my angle of refraction to be angle of incidence by 2. Now let us use the formula n1 into sin I is equals to n2 into sin r. N1 is okay, consider a light ray traveling in air. Initially it is air. Air means vacuum only. Okay, refractive index 1. By default we consider the refractive index of air and vacuum to be same, that is 1. So 1 into sine of angle of incidence is equals to refractive index of medium 2 is root 2n into sine of r, and r is equals to I by 2. Now sine I can write 2 sine I by 2 cos I by 2. Sine 2 theta is 2 sine theta cos theta. Yeah. So 2 sine I by 2 cos I by 2 is equals to root of 2n sine of I by 2. So here sin I by 2 is getting cancelled, and I can write here cos I by 2 is equals to root of n by 2. Cos I by 2 is equals to root of n by 2. So I can say that I comes out to be 2 cos inverse root of n by 2. Simple. 2 cos inverse root of n by 2. Angle of incidence is D. Okay, just using Snell's law. Now lateral shift in case of refraction through a glass slab, rectangular glass slab we are taking. Let us take a rectangular glass slab. This is our glass slab. Okay, a ray is incident on this at a particular angle. Let us take like this. Like this. Yeah. Let us draw normal here. I'm drawing normal with dotted line. Okay. It will be refracted. How it will bend? Along the normal. Okay, towards the normal it will bend, isn't it? Why? Because it is going from air to glass. So glass is denser. So it will bend like this. Solid. So it will bend like this. Okay, towards the normal. This angle is coming to be very small. I want to make it a bit bigger so that you can understand it in a better way. Let me redraw it. Okay, just redraw it so that you understand properly. Again, I'm drawing. So make this angle to be a bit bigger. Here it is fine. Yeah, I hope so. So this ray is coming like this. Let us draw the normal now. Again, I'm taking a dotted solid white line, dotted white line, not solid. Okay, this is my normal. This will bend towards the normal. It will bend towards the normal somewhat like this. I hope you are able to see this angles very clearly. Okay, now again here refraction will happen. Let us draw normal on this surface. Okay, yeah, it looks fine, I hope. Okay, now my angle, my ray will be refracted, it will bend away from the normal, okay. So away like this, and it will be reflected again at the same angle. If this angle is my eye, again this angle will become eye. Why so? 1 into sin I is equals to here mu into sin r, then again mu into sin r is equals to 1 into sin I. So this angle has to be I only. Okay. Now there is lateral shift between this ray and this ray. Which shift I am talking about? Which shift? If you extend this line, okay, let me take the same solid color, same color, not solid, okay, dotted line. So if I extend the incident ray, you're able to see there is shift. How much is the shift? You can draw perpendicular here. So let us draw this perpendicular. Which color? Let us take this color. So this is my perpendicular here, 90 degree. So this much is my shift, and let us denote this shift with a D. I'm taking the thickness of this slab to be T. Now let us try to relate D and T. So it's just geometry things, basic things. This is I, the angle of refraction is this R, this angle is I minus R. Yeah, what is this? Total is I. When I extended this, total is I, this was R, so this angle is I minus R. Okay, now yeah, now let us extend it, this white line, dashed white line, let us extend it till here. Now if this is D, if I ask you how much is this hypotenuse, what it will be? D sine of I minus R, D by sine of I minus R, isn't it? Yeah, because this is I minus R, this is 90 I minus R, okay, 90 minus I minus R, okay, brackets. So when you take this component here, so this will become D by sine of that. So if I mark this hypotenuse here, this is basically D by sine of I minus R. Now I got the hypotenuse now. If I take this component, cos of this R, what it will become? This will become T. So this T comes out to be my D by sine of I minus R into cos of how much angle? R. See this again. This hypotenuse is D by sine of I minus R. Take the cos component, it will become T. Okay, from here I can say my D comes out to be T sine of I minus R divided by cos of R. Need to remember this formula? No, don't remember this formula. Just quickly draw the diagram if it is asked, and then you can derive it. Okay, so need not remember this formula separately. Let us do a question on this. A ray of light is incident at an angle of 60 degree on the glass slab of refractive index √3. After refraction, the light ray emerges out from the other parallel faces, and lateral shift between incident ray and emergent ray is coming out to be 4√3. Okay, and the thickness of the glass slab is. Now if this question comes in means, quickly I will draw the slab, I will show the angles, and you see here this angle of incidence is 60, refractive index is √3, angle of refraction will become 30 degree when you write it. Okay, so everything is very easy. So if you draw the ray diagram quickly, you can solve it that way. But as I have done this effort already, so I'll put the values. So the lateral shift comes out to be T sine I minus R by cos R. So the what is 4√3? lateral shift between the, now we need to find the thickness. I need to find T. So T is basically D cos R divided by sine of I minus R. What is I? I is 60 degree. What is R? You can write 1, mu1 is 1 into sine of 60 is equals to mu2 is root 3 into sine of R. Just write Snell's law, and sine 60 degree is root 3 by 2. From there you can say sine R is equals to 1 by 2. R comes out to be 30 degree. R comes out to be 30 degree. Now put the values. So T comes out to be D. What is D? 4 root 3. 4 root 3 into cos of, what is the R? 30 degree divided by sine of 30 degree. 30 degree is, sine 30 is 1 by 2, cos 30 is root 3 by 2. Yeah, yes. So this will become root 3. So what is 4 root 3 into root 3? That is 4 into 3, 12. So this becomes 12 centimeter. Okay. I did this formula because I derived this formula, therefore I put the values. Otherwise, I will be drawing the ray diagram. I will be drawing the ray diagram showing the angle of incidence 60, marking the angle of refraction 30 degree. In that triangle, quickly I will relate my thickness of the slab and the lateral shift. Now, apparent depth and normal shift. Okay. Let us take a container. Let us take a container filled with some liquid. Which color should I take? Let us take yellow itself. So this container is filled with some liquid. Oh, solid line. Okay, it is having some liquid inside it. Let us take, this is the surface of the liquid. Now you put a coin at the bottom. So here the coin is kept. You are viewing this coin from the top. Okay, you are seeing from the top. You are seeing from the top. Now we all have this experience that we will see the coin is a bit shifted towards us. How much is that shift that we need to find here? Okay. So the rays are coming, you can say, this is the normal, they'll bend towards the normal. Yeah, so they'll bend towards the normal. Let me make this a bit more fine. Okay. I'm drawing this ray diagram, or you can say the rays from this point are reaching that point there, other way. Okay, anyways, it's the same thing. Now, when we visualize it, the refraction phenomena is there. Okay, refraction phenomena is there, the ray light are bending, but for us, so for us, like we visualize like the light is just traveling in the straight direction. Okay, we visualize it like this. So for the appearance of this coin, okay, you extend these line on the other side, these refracted rays on the other side, and this coin will appear somewhat here. This coin will appear somewhat here. This is what happens. This is the phenomena due to which the coin appears to be a bit lifted from the bottom. Now let us take here the refractive index is N1, here the refractive index is N2, okay. The angle of incidence is, this is I, okay, and here this a bit difficult to mark, let me make it a bit more fine. So the angle of refraction is this is my R, okay, this small angle, okay, and this total is my I, this is I. And now extend this line till here. Now we are having two right angle triangles. Yes, we are having two right angle triangles. Okay, so for both the right angle triangles, which two right angle triangles? So let us take first this as, first I am talking about this right angle triangle. First I am talking about this right angle triangle. Okay. So for this right angle triangle, if I say what is tan of this, upper angle was R, okay. This angle was my R, okay. So in this right angle triangle, if I write my tan R, what is that? That is equals to this. How much is this? Let us take this to be some value, some x, okay. This is my x divided by this total depth, and this is my actual depth, okay. So we may write this as h, okay. So this is x divided by h. Now take another right angle triangle. Which one here? I am now talking about this right angle triangle, okay. So in this right angle triangle, if I write 10, what is that small angle? What is that small angle? I, okay. This angle is I, upper one. So there I will say 10I, that comes out to be, this base will be x only, x divided by h dash. Let us take this as my h dash, okay. Is this clear? Now I am considering that I am viewing just normally. The angle of incidence and angle of refraction are very small. Tan R is nearly equals to sin R. Tan I is nearly equals to sin I. And I know N1 sin I, I'm using Snell's law, is equals to N2 sin R. Put the values, no, expression I am talking about. So N1 into sin I is x by h is equals to N2 into sin R is x by h dash, x got cancelled, I got h dash equal to, this was h, okay, h dash equal to h divided by n1 by n2. What? H dash, okay, this was x by h dash, okay. So let me write it again here. So h dash divided by h comes out to be n2 by n1. Everything is fine. This was h, this was h dash, okay. There is some mistake, I think. N1 10R, okay, that was my R angle, yeah, and this was my I angle. So 10R is equals to x by h, yes, and 10I is equals to my x divided by h dash, okay. 10I I wrote as nearly sin I, 10R I wrote as sin R, okay. So okay, when I was putting the values I did a mistake here, Yeah, so therefore the relation was coming wrong. Sin I is this. So n1 into x by h dash, this is my sin I, yeah, is equals to n2 into sin r is this, which is x by h. Now here my x is getting cancelled and I can say that my h dash comes out to be h divided by n2 by n1, and this I'll say h dash comes out to be h divided by n21. Okay, sometimes we use mu for refractive index, sometimes we use n for refractive index. So many times you may find mu to 1, many times you may find n to 1, same thing. So this I can say my apparent depth comes out to be actual depth divided by n. N to 1 I am taking as n. What is n? Refractive index of the medium. Which medium? Refractive index of second medium with respect to the first medium. So refractive index of the medium in which the object is there with respect to the one with which we are seeing. Okay, so with respect to us, like that. Medium 2 with respect to 1. From this, in mains, questions are asked. So just try to see that this h becomes h by mu. That's all. Okay, we are having this formula. Okay, we are having this question. This was asked in 2024. Two immiscible liquids, refractive index are given as 8 by 5 and 3 by 2 respectively. Okay, the height of each column is 6 centimeter. The coin is placed at the bottom. For near normal vision, the apparent depth will be. Now these are two different mediums. This is having refractive index 3 by 2. This is having 8 by 5. When you find the h apparent, so for this it will become 6 by mu. Mu is 3 by 2 plus this will appear as 6 by mu. Their mu is 8 by 5. That's all. h1 by mu1 plus h2 by mu2. This becomes my h apparent or h dash. Okay, so what it is now? 6 by, so this will become 3 into 2, so 4. So 4 plus what it is? This is 3 here, this is 4, so 15 by 4. So this is 31 divided by 4 and x comes out to be 31 or alpha comes out to be 31, yeah, alpha. This much centimeter. Easy? Yes? Okay. Another question. Now in this question, the two things are moving. Okay. Now if let us take here, I move this coin with some velocity and ask you what will be the velocity which that will appear for you. What you will do? Just differentiate this. Just differentiate this expression, isn't it? Yes. Same thing. Here. Now first let us try to understand. The fish rising vertically upward with a uniform velocity of 8 meters per second. So this is the surface of the water. Okay, and we are having our fish here. Will I be able to draw it? Okay, this is the fish and it is rising upward with a velocity of 8 meters per second. Observes a bird is diving vertically towards the fish with the velocity 12 meters per second. Now a bird is there, okay, which is diving vertically downward with speed. What? We don't know. It is observing the bird to be coming with 12 meters per second. This is 12 meters per second is not the actual speed of the bird. It is, the fish is observing it to be 12. Okay, this is with respect to the fish. Getting it? Okay. If the refractive index of water is 4 by 3, then the actual velocity of diving bird, we don't know. Let us take this velocity to be velocity of bird, okay, to pick the fish will be, how much is this VB? Now with respect to fish, this appears to be coming at a velocity of 12 meter per second, that we know. Let us consider this is y1, let us consider this is y2. Actual distances I am marking. Now if you ask me how much total height this total separation fish will see, so I'll say y with respect to fish, okay, this much will appear y2 only, because this is water only, she is inside water, so this much will appear y2 only. So y2 plus this, how much it will appear? It will become 4/3 times of y1. y1 divided by the refractive index of that medium with respect to this. That medium is having refractive index 1, this medium is having refractive index 4/3, so 1 divided by 4/3, so this will become 4/3 into y1. What I am saying, this will be y1 divided by refractive index of this medium of the bird with respect to the medium in which the fish is there. So this is what fish is able to see. Now differentiate it. So dy dash by dt, this will be my dy2 by dt plus 3/4, what it will become? 4/3, sorry. Yeah. Plus my 4/3 divided by into dy1 by dt. With what rate y2 is changing? 8 meter per second. Negative. It is decreasing. So minus 8. With what rate y1 is changing? We don't know. VB. I consider that to be VB. So minus VB, it is decreasing. So minus VB. So minus 4/3 VB. This is the rate with which it is decreasing. So the total velocity, if you ask me the magnitude, so magnitude, okay, so magnitude of dy dash by dt is my 8 plus, why it is coming negative? Because the fish is able to see, it is moving towards me, therefore it is negative. So 8 plus 4/3 into VB, and this is the velocity which fish is seeing for the bird, of the bird. Got it? 4/3 VB comes out to be 12 minus 8, how much is that? 4. This got cancelled. VB comes out to be 3. So the bird is moving with velocity 3 meter per second. This was asked in 2023. Not that difficult question, only when you understand the concept. When you understand that, just you need to differentiate that equation, you'll get the relation. Then it is not difficult. If you don't understand this concept, then you will be very much confused. What will be the velocity there? How to write that? Then you will be confused because different medium are there. So see it again. And if you are having any doubt here, okay, so make sure you mention in the comments. If you are having any query to ask, you can mention that in comments. We will respond. Okay. Now let us discuss the phenomena of total internal reflection, TIR. So let us take, this is the separation between the two mediums. A light is going from denser medium to rarer medium. I am considering this upper one as my rarer medium and the lower one as my denser medium. Let me write here. Let us take here the refractive index is what you will say, let us take this as my N2, I am taking this as my N1, okay, and the light is going from denser to rarer from N2 to N1. Like this. It is coming. At some particular angle, you will draw the normal here. So this is my normal. Yeah. Okay. Now what will happen? Refraction is happening. So it will move away from the normal because it is going from denser to rarer. It will move away from the normal. Oh. Bend away from the normal. This is my angle of incidence. This is my angle of refraction. If I increase this angle of incidence, angle of refraction will further increase. Again, if I further increase this angle of incidence, angle of refraction will further increase. Let us take it becomes 90. After that, if I increase this, what will happen? The light ray cannot enter the other medium, isn't it? Yes, then reflection will happen. Refraction will not happen. Okay, so let us take, I am increasing now. Okay, I am increasing now. Now, I am increasing this angle. Let us take from this source. Okay, here I increased this such that my angle of refraction becomes 90 degree. Okay, this is normal here. Okay, so here my angle of refraction becomes 90 degree. Just the ray is moving just like this along the surface. It is going like this. This becomes 90 degree. And this angle we say as my critical angle, we denote with theta c. Critical angle, why I am saying critical? Because if this is the critical, if you increase little bit from this, the ray will get reflected. So let us take another ray from the same source, okay, which is incident at an angle which is greater than this theta critical. So here certainly if I draw this normal, this angle is greater than theta critical. If this is greater than theta critical, now it has already reached 90. How much it can bend? Now if it bends further, it will not enter in the first medium, it will go to the second medium. If it is coming back to the same medium means what? Reflection is there. And if reflection is there, angle of incidence is equal to angle of reflection. Now this reflection is taking place. If this angle is theta, this angle is theta. Okay, so here it is reflection. Okay, let me take yellow color. Here this is reflection. Here critically refracted. Here it was refraction. Okay, so if I say that my F angle theta becomes greater than this critical angle, reflection will take place, or this is the internal reflection. Okay, therefore we say this is total internal reflection. Okay, so total internal reflection will happen. No part of the light is refracted. Okay, so it is fully reflection is happening, therefore total internal reflection. Can we find theta critical? Yes. Let us use Snell's law here. So I will say mu1, this medium is my 1, so n1 sine theta critical is equals to there n2, there the medium is having refractive index n2 into sine of my 90, yeah, there the angle is 90. What is sin 90? 1. So sin theta critical comes out to be n2 by n1. Okay, so I can say this is 1 by n12, or just say sin theta critical is equals to 1 by n, where n is the refractive index of denser medium with respect to rarer medium. Refractive index of denser medium with respect to rarer medium. Refractive index of denser medium with respect to rarer medium. Okay. So TIR will happen when the angle of incidence is greater than the angle of this critical angle, greater than the critical angle, that is theta c. So if theta is greater than theta c, TIR will happen. And theta c we got. How to write theta c? Now we are having a question on this. This was asked in 2021. Let us read it. A ray of laser of wavelength 630 nanometer is incident at an angle of 30 degree at diamond air interface. It is going from diamond to air. Okay. The refractive index is this. Okay, and that of air is this. Choose the correct option. The angle of refraction we need to find. So first check whether it is possible for this ray to refract or not. If any ray which is going from denser to rarer, we always check whether it is possible to refract or reflection is taking place. Okay, always whenever a light ray is going from denser to rarer, check the value of angle of incidence. If it is less than theta critical, the ray will pass. If it is greater than theta critical, the ray will not be able to pass. So let us find theta critical here. So I will say my sin theta critical is equals to 1 divided by refractive index of denser, means diamond. What is diamond? 2.42 with respect to the rarer, here air, divided by 1. So this is coming out to be 2.42. And what is sin I? This is 30 degree. My sin I is equals to 1 by 2. 1 by 2 is greater or smaller than 1 by 2.4? Certainly greater than 1. Okay, so greater than 1 by 2.42. Okay, so if I is greater than theta critical, TIR will take place. TIR will happen, it will not be able to enter the other medium. Not able to enter the other medium. Okay. Now let us talk about prism. Next topic. Prism is a bit interesting topic. Here we are having you can say 3 surfaces. This one surface, this bottom surface, and this side surface. Okay. 3 surfaces are there. Ray is incident on one of the surface. This angle we call at angle of prism. This is my angle of prism. Okay, A is my angle of prism. Now it is incident at some angle I. Refraction will take place. This is normal on this surface. This first angle of refraction I am taking as R1. Okay, now it will go refract on the second surface. I drew the normal on the second surface. This second angle of refraction I am calling as R2, and finally my ray emerges at an angle E, and we call E as the emergent angle. Okay, and this is my emergent ray which finally emerges out of the prism. Now let us try to find some of the relations for this ray. Let us try to relate R1, R2 first. Now I'm going to talk about, okay, first of all let us write the angle. How much is this is normal here? How much is this angle? If I ask you, how much is this angle? This total is 90. Why so? Because this was normal. Okay, this is R1, so this is 90 minus R1. Similarly, how much is this angle? this total was 90, so this is 90 minus R2. Now, see this right angle triangle. Sorry, not right angle. See this triangle. This is not a right angle triangle. So see this triangle. In this triangle, the sum of the three angles is any triangle. Sum of the three angles is 180. Okay, so write that the sum, make that equal to 180. How much is that? Upper one is A, plus this was 90 minus R1, plus the other one, this was 90 minus R2, and this is equals to 180. 180 is 90 plus 90. So I got my angle A is equals to R1 plus R2. This is one relation I got, that the sum of the two refracted angles R1 and R2 is equal to my angle of prism, that is A. This is important. Okay, keep this thing in mind. I'm highlighting it so that don't forget. Now if I ask you how much is the total deviation, total deviation means initially this ray was going like this, so this was the direction. Finally the emergent ray is going like this, the angle between the two, it was going like this, it deviated like this, so this is the angle of deviation. How much is that angle of deviation? The sum of the two deviations. So first it was going like this, it went here, so how much is the deviation? This much angle is the deviation. What is this angle? Can you write this? How much is this angle? I can say that this is I, so this total is I, this total is I. Out of that total you subtract R1. So I minus R1, getting it? I minus R1 is my this angle, deviation there. Total I, okay, these are opposite angles. Total I minus R1. So first deviation is I minus R1. Second deviation, now it is going like this in this path and then went it here. So this much is the deviation. Okay, how much is that? This is R2. So this is my R2. Okay, so I can say this deviation is E minus R2. So plus E minus R2. Is this clear to you? Total deviation, I wrote it like this. So deviation, and you see both the deviations are in same sense, therefore I am using plus. If they would be opposite, I would be using minus. They are in same, therefore I used plus. So I minus R1 plus E minus R2, I can write this as I plus E minus of R1 plus R2. What is the R1 plus R2? That is A. So I plus E minus A. This is the formula for angle of deviation of a prism. Very, very important. Keep this thing in mind. I plus E minus A, where I is the angle of incidence, E is the angle of emergent, A is the angle of the prism. Now, if I try to plot this angle of deviation with incident, okay, I am changing my incident angle and I see how much is the deviation. Now I am plotting this angle of incidence and angle of deviation, and this curve will come out to be like this. At a particular angle, this deviation is minimum, and this deviation is minimum when angle of incidence is getting equal to angle of emergent. When I is becoming equal to E, when I is becoming equal to E, my deviation is minimum. What is deviation? Deviation is I plus E minus A. So I can say deviation minimum, I am denoting with M. Okay, deviation minimum is 2I minus A. If I is equal to E, I can say my R1 is also equal to R2, isn't it? You use Snell's law here, you use Snell's law here. Here you will say 1 means this refractive index, I am taking that as here. So 1 into sine I is equals to mu into sine R1, and here 1 mu into sine R2 is equals to 1 into sine of E, which is I only. Okay, it means R1 has to be equal to R2. Yes. So R1 is equals to R2, therefore they are half of A, because R1 plus R2 was equal to A. If R1 is equals to R2, I will say R1 is equals to R2, which is A by 2. Now use Snell's law. At which surface? At this surface. So I'll say, when I use the Snell's law, I'll say that is 1 into sine I. Okay, so 1 into sine I is equals to refractive index there, mu into sine of there, what is that angle of refraction? A by 2, A by 2. Okay, from here, okay, anyways, so from here I can say sine I is coming out to be mu into sine A by 2. From this expression I can say I is equals to minimum deviation plus A by 2. Put it here, sine of minimum deviation plus A by 2, this is equals to mu sine of A by 2. So I related that mu comes out to be sine of A plus del minimum by 2 divided by sine of A by 2, and this expression is very, very important. If a question is coming from Prism, that question will be almost sure from minimum deviation, almost sure. There are few things they can ask from other things, but if some question is coming, almost you can take it will be from minimum deviation thing. So this formula is must to remember. Don't go for derivation in the exam. Remember this formula. Sine A plus del m by 2 divided by sine A by 2. This is equal to the refractive index. Let us solve a question on this. If refractive index of material of prism is cot A by 2, where A is the angle of prism, then the angle of minimum deviation will be. Mu is given as cot A by 2. Angle of minimum deviation I need to find. So I will say mu is equals to sine of A plus del by 2 divided by sine of A by 2. Mu put as cot A by 2. So cot A by 2 into sine A by 2, I am taking this on other side, is equals to sine of A plus del by 2. So here this becomes my what? Cot A by 2 is cos A by 2 by sin A by 2. Sin A by 2 will get cancelled. This will become cos A by 2. So cos A by 2 comes out to be sine of A plus del by 2. Okay. So cos A by 2 is coming out to be sine of A plus del A by A plus del by 2. So I can say A by 2 is basically equals to 90 minus of A plus del by 2. From here I can say this A by 2 will come on the other side, so this will become A is equals to what? 90 minus del by 2. What we need to find? The angle of minimum deviation, del. So this will become del comes out to be 180 minus 2A. Oh, don't remember this, it's not a formula. So this is coming out to be 180 minus 2A. Everything is fine? Yeah. 180 minus 2A. Pi minus 2A. First option. Okay, just use the formula. That's all. Another question. A monochromatic light is incident at a certain angle on an equilateral triangle prism and suffers minimum deviation. If the refractive index of the material of the prism is √3, then the angle of incidence is. what it is saying, it is mentioned that monochromatic light is incident, certain angle, okay, suffers minimum deviation, means minimum deviation condition is happening. Now angle of, if the refractive index of the material is given mu, that is √3, then angle of incidence IA he is asking. And this prism is an equilateral prism. It means that my A is equals to 60. Now how to do this in a very simple way? Let us take equilateral triangle, destroy it. Minimum deviation is happening, angle of incidence is I, R is A by 2. This angle is A by 2, we know that at minimum deviation condition. So just use Snell's law here. So what you will say? You will say that 1 into sine I is equals to mu into sine of R, which is A by 2. Now write it, sine I is equals to mu is √3 into sine of 30. 60 by 2 is 30. So this comes out to be √3 by 2. It means I comes out to be 60 degree. √3 by 2 is 60 degree. Okay. Yeah. Now deviation by a thin prism. If a thin prism is there, then this angle A is very, very small. So this minimum deviation thing that we wrote, mu was sine of A plus del by 2 divided by sine of A by 2. Angle is very, very small A, del will also be very, very small. Sine theta is nearly equals to theta. So you can write this as mu is equals to A plus del by 2 divided by A by 2. In ray optics, there are so many approximations. When we derive mirror formula, that is, there is approximation. When we will derive lens formula, there is approximation. On spherical surface, there will be an approximation. Here, thin prisms, there is approximation. So many approximations we take. You see, like hardly is anything which is perfect. Like there is no approximation in this. So from here, if I find the minimum deviation, it will become mu times of A. This is equals to A plus del. So deviation comes out to be mu minus 1 into A. For a thin prism, the deviation nearly comes out to be mu minus 1 into A. Okay, for thin prism, not for any other. Thin prism means the angle is 5 degree, 6 degree, 10 degree, like that. Let us have a question on this. A thin prism P1 with angle 6 degree and made of glass of refractive index 1.54 is combined with another prism P2 made of glass of refractive index 1.72 to produce dispersion without deviation. Now dispersion, we will talk about what is dispersion, but he is mentioning that there is no deviation. It means whatever deviation first prism is doing, the same deviation in opposite sense the second prism is doing. So the two prisms will be connected in this way actually, so that they cancel each other deviations. So magnitude wise, I will say deviation by first prism is equal to deviation of second prism. This is mu1 minus 1 into A1 is equals to mu2 minus 1 into A2. This I will say. Now write what is mu1, what is mu2. What is mu1? 1.54. What is A1? 6 degree. So 1.54 minus 1 is 0.54 into 6. This comes out to be mu2 is 1.72 minus 1 is 0.72 into A2. A2 is, what is A2? Okay, A2 we need to find. A2 we need to find 18 into 3, 18 into 4. So A2 is 3 into 6 by 4. How much is this? 9 by 2? 4.5. 4.5. D option, 4.5 degrees. Yes, everything was in degree, so here it was in degree 6, therefore it is in degree. Okay, easy. So if some question is coming from prism, almost certain this will be from minimum deviation formula related. Like this was thin prism, so in thin prisms mu minus 1 into A only we use. Now dispersion of light. What is dispersion of light? Now white light is having, as you know, in visible range we are having these 7 wavelengths. Okay, general, like not exactly these 7 wavelengths, I'll say these 7 colors we are having. Now when this light is traveling in air, okay, the speed of light was 3 into 10 to the power 8, so all the colors were traveling with the same speed. Now they are entering prism. Now the refractive index for each color will be different. Why so? Why the refractive index is different for each color, not same for all the colors? Now if we say that the refractive index is equal to, if we say the refractive index that is equal to speed of light in vacuum divided by speed of light in medium. Now speed of light in medium, I can say this is C divided by speed of light in medium is frequency into wavelength. Frequency will remain the same when light is going from one medium to another medium, frequency will remain the same, frequency will not change. So frequency is the same, wavelength is changing. Okay, so wavelength is different, frequency is the same, wavelength is different. Now if wavelength is different, my refractive index will be different. All the colors are having different wavelengths, so all the colors will have the different refractive index. And when I am going from you can say this is Vibgyor, my wavelength is increasing in this sense, so lambda is increasing. So if lambda is increasing in this sense, my refractive index will decrease. So in this direction, my refractive index will decrease. Lesser the refractive index, lesser will be deviation. Deviation is proportional to refractive index. Lesser the refractive index, lesser will be my deviation. Okay, so red color will be least deviated, my violet color will be greatest, you can say the deviation will be highest for the violet color. So when this light is coming here, you see the deviation is highest for the violet color and for the red color it is least. Okay, so red color deviated the least, violet color is deviating the maximum. This diagram is not up to the mark exactly. Okay, so I took this image, but this diagram is not up to the mark. So the deviation when it will happen, okay, so go like this, different colors. They will go like this. Okay, yeah. So there I'll say this is VIBGYOR. Deviation is maximum for violet and minimum for the red color. Now these are, this phenomena we say dispersion. Okay, the light is individually divided into, you can, like, you are visually able to see the different 7 colors in the white lights. Okay, so white light bifurcated in the these 7 different colors, and this phenomena we say this is the dispersion of light. Okay, this is the dispersion of white light. Now for mains I am talking about, we need not go into much detail. Okay, we need not go into much detail how much is the dispersive power and all those things, but try to understand this thing, that dispersion happens due to this phenomena, and this is the basic fundamental things which are required to understand it. So we are not going into much detail how much is the dispersive power and how much is that, those things. No, that is not required. Okay, let us read this question. A thin prism of angle 6 degree and refractive index of yellow light 6 degree and refractive index of yellow light is 1.55 is combined with another thin prism of 5 degree and refractive index for yellow light as 1.55, the combination produces no dispersion. The net average deviation is. Now they are saying no dispersion, and what is the net average deviation? So what you need to do? Dispersion is not there, so don't worry. Okay, so just write the net deviation. They are connected in opposite sense, so deviation will be in opposite sense. So total deviation I will say that is mu minus 1 into a1, mu1 minus 1 into a1 minus mu2 minus 1 into a2, the deviation of the second. They are in the opposite sense, therefore I am subtracting it. Just do it like this. Okay, so what is mu1 minus 1? 1.55 minus 1 is 0.55 into a1 is 6 degree minus mu2 minus 1 is 0.55. I think there is a mistake or not, don't know. So I think it should not be 0.55. There is some data missing. First is 0.55, another would be something different. I think there is some mistake in this, so don't worry. So whatever it is, okay, whatever it is, you can put the values, and you can put the values, and this will become your total deviation. Total deviation. Whatever you will get from here. So mu1 minus 1 into a1 minus of mu2 minus 1 into a2. Just you need to tell the magnitude. So if one is coming, you can say I am subtracting the second one from the first one. It may be other way also, like it may come negative, so don't worry. Refraction from spherical surface. Now we are moving to another next topic, from spherical surface. Now let us take a spherical surface. This is a spherical surface. Draw the principal axis. So this is our principal axis. Let us take an object here on this principal axis. Let us take here. I need to find where the image will be formed. Take two rays from this at least. So I am taking this as my first different color. So I am taking this as my first ray, which is passing straight. Okay, it will pass straight like this. Second ray I am taking, let us take here. So first of all, on this surface, spherical surface, draw the normal. So let us take the center of curvature. Center of curvature is somewhat here. Okay, now this is the center of curvature. Okay, let us take it a bit nearby. Okay, let us take the center of curvature is here. Now from the center of curvature, join that point, that is normal. So from center of curvature, join that point. Okay, this becomes the normal. Yes, and this ray is going from rarer to denser. It will bend towards the normal, so it will go like this. Okay, so here is my image that is formed. Here was my object. Okay, and this is my pole. Now the angle of incidence is this, angle of incidence. Angle of refraction is this, angle of refraction R. Let us take this as my point M. Let us draw normal here. Okay, and what else? Let us take this angle as alpha, this angle as beta, this angle as gamma. Okay, then I can say, now carefully see. Now when I say carefully see, like you have to Focus a bit. I am talking about which triangle? I am talking about this triangle. This triangle I am talking about. In this triangle, I is my external angle, alpha and beta are internal angles, so I is equals to alpha plus beta. Okay, now let us talk about, see carefully again, put focus, see carefully again. I am talking about this triangle. This triangle I am talking about. In this triangle, beta is the external angle, r and alpha, r and gamma are internal angles. So beta is equals to r plus gamma. Write it. Beta is equals to r plus gamma. Okay. So I got from here my r is equals to beta minus gamma. Now we can use Snell's law here at this point in time. I can say, let us take here the refractive index is n1, here the refractive index is n2. So I can say n1 into sin I is equals to n2 into sin r. So n1 into alpha plus beta, sine of alpha plus beta, this is equals to n2 into sine of r, which is beta minus gamma. Now again assumption here. What is the assumption? That this point I am taking very near here, okay, very near to this, and this my angle of incidence is very small, angle of refraction is also very small, alpha is small, beta is small, gamma is small. All angles are small, so I can say that my sine alpha plus beta is nearly equals to alpha plus beta, and alpha I can take nearly equals to 10 alpha. So I can write this as n1 into my alpha plus beta, this is equals to n2 into beta minus gamma. Now n1 into alpha I can write as 10 alpha, so 10 alpha will be mp divided by op, 10 alpha is mp divided by op, plus beta is mp divided by pc, yeah, mp divided by pc, beta again mp by pc, gamma is this is my gamma is mp by pi. mp everywhere will get cancelled. Okay, now again using the sign convention. What is the sign convention? In the direction of light, if you measure the distance, all the distances along the principal axis will be measured from P. If you measure a distance in the same direction as that of the light, that is positive. In the opposite direction, that is negative. If you measure a distance perpendicularly above, that is positive. Down, that is negative. Okay, so what is OP? By the way, OP is the distance of object U. Okay, that is the distance of object, and pi distance of image, and this is the radius of curvature r of this surface. So putting with the signs, so n1 I used n1 and n2, but generally I'll say that for spherical surface we see the formula that in terms of mu. So can I write mu in place of n? That will be better, because this is what you have seen everywhere, so will be very easy to recall that. I'm just writing mu instead of n, don't get confused, no change, just writing instead of n, just writing mu, mu1, mu2, mu1, mu2, mu1, mu2, mu1, mu2, let us take mu1, mu2. Okay, now putting with the signs, mu1 into OP is minus u, I am measuring in this direction. PC is plus V, I am measuring in this direction. PC is plus V, PI is plus R, measuring in this direction. Okay, yeah, that is in this direction, so plus that, minus 1 by R. Okay, now what was here? It was plus. Okay, now let us take this u on the other side though, so this will become mu2. Okay, now there is something I missed here, I think. What is that? Everything seems fine by the way. PC is, okay, I did a mistake. PC was this distance, that was R. Okay, PI was the distance. Okay, while putting this, I did a mistake. Let us correct it again. So PC was this distance, that is R plus R. Here also PC, so PC is plus R. PI was plus V, so V. Now, okay, now it seems fine. Okay, 1 by V term I am taking on the left, so this will become mu2 by V minus mu1 by U is equals to mu2 minus mu1. I am taking that 1 by R terms to the right, so this will become mu2 minus mu1 divided by R. Formula for refraction on the spherical surface. I did derivation for you to understand it in a better way. Okay, so formula becomes mu2 by V minus mu1 by U is equals to mu2 minus mu1 by R. Mu2 is the refractive index of the second medium, mu1 refractive index of first medium, R is the radius of curvature. Okay, V and U. Now everything, whenever you put with proper sign convention. If you do one mistake, everything will be wrong, as in case of mirrors also, spherical mirrors also. Like if you put the distances in a wrong way, it will be wrong. Now we are having this question, let us read it. Region 1 and region 2 are separated by a spherical surface of radius 25 centimeter. An object is kept in region 1 at a distance of 40 centimeter from the surface. Okay, 40 centimeter from the surface. So this is 40 centimeter. Okay, one thing, let me check here. Okay, fine. 40 centimeter from the surface. The distance of image from the surface is where the image will be formed. This center of curvature distance is given, means the radius is 25 centimeters. Just use the formula here, mu2 by V minus mu1 by U is equals to mu2 minus mu1 divided by R. What is mu2? 1.4. So 1.4, where should I write it? There is less space. Let us write it here. So 1.4 divided by V, we need to find, minus mu1 is 1.25. So 1.25 divided by U. What is U? From here you measure on this side. So this is minus 40. So minus 40, this is equals to mu2 minus mu1. This is 1.4 minus 1.25, that is 0.15. Okay, 1.4 minus 1.25 divided by R. R you measure from this on the left, so minus 25. Okay, now you can do the calculations and you can find V. So take a pause in this video, do the calculations, put your answer in the comments with timeline, and then come back. Do it quickly. Okay, I hope you are back. Now this was one surface. If we take two spherical surfaces, then it will become a lens, and we have different types of lens. Here this surface is convex, this is also convex, so convexo convex. This is having equal radius, okay, both convex, so we say equiconvex. Okay, one plane surface, another convex surface, plano convex. One concave, another convex, okay, this becomes concavo convex. Okay, and yeah, and similarly we have this was convex and concave. Okay, similarly here we are having biconcave lens, okay, and we are having equiconcave lens, then we are having plano concave lens, and we are having convexo concave lens. Most of the times we will be talking about equiconvex lens and equiconcave lens, unless until they mention specifically. I'm saying unless until they mention specifically. If they go, they may go till here. Otherwise, most of the times we will be talking about general lenses. Okay. Now, lens maker formula. Take two surface. Let us take this surface is having radius R1. This surface is having radius R2. Okay. And let us take here the refractive index is mu1, here it is mu2, here it is mu1. You take an object here. So due to the first surface, you write the spherical refraction formula. Okay, what is the formula for refraction on spherical surface? Mu2 by V minus mu1 by U is equals to mu2 minus mu1 by R. Okay, this is. Now apply this for both the surfaces. Apply this for both the surfaces. When you apply for first surface, the image you will get, that image will behave as object for the second surface. Then apply for the second surface, then you simplify, and when you will simplify, it will become like 1 by V minus 1 by U is equals to mu2 by mu1 minus 1 into 1 by R1 minus 1 by R2. Okay, or you can say it as mu21 here, or you can say this as mu relative here, anything, or and that I'm writing as mu only. So mu minus 1 into 1 by R1 minus 1 by R2. This becomes my 1 by V minus 1 by U. You will get it like this. Mu is the relative refractive index. Okay, so refractive index of lens with respect to the medium. Now we know that if parallel rays comes, the image is formed at focus. Okay, so you take your object to be infinity, your image will be formed at focus. So 1 by f minus 1 by infinity, this becomes mu minus 1 into 1 by r1 minus 1 by r2, and this becomes the lens maker formula. Why we call this as a lens maker formula? Because if you want to make a lens of particular focal length, you can choose the refractive indices and the radius of curvature for the first and the second surface accordingly. Okay, so this formula we call as my lens maker formula. And 1 by f is my this, because this thing is anyways constant. I also got my 1 by f is equals to 1 by v minus 1 by u, and this becomes my lens formula. This is my lens formula. Okay, this is lens maker formula and this is my lens formula. Is this clear? Okay. And also here I am considering one assumption that this is very thin lens. That assumption is there. Okay, so this is not a thick lens. Here the distance between the two surfaces here is very small. So this formula is for thin lenses. Okay, focal length of lens inside water. Now inside any medium I can say 1 by f is equals to mu relative minus 1 into 1 by r1 minus 1 by r2. This is general formula. So if it is talking about inside water, so you take the relative refractive index with respect to water. Okay, take the refractive index of lens with respect to water. So this will become refractive index of lens divided by refractive index of water. That's all. R1, R2 will remain the same. That's all. Very easily you can write it. Okay, now let us do this question. For the thin convex lens, the radii of curvature are 15 cm, 30 cm. The focal length of the lens is 20 cm. The refractive index of the material is. Okay, so 1 by f is equals to mu minus 1 into 1 by r1 minus 1 by r2. If anything, if he is not saying where the lens is put in which medium, so by default consider that to be in air. So focal length is what? Focal length is 20. So 1 by 20 is equals to mu minus 1 into 1 by r1 is 1 by, okay, 1 by r1 is the one thing. Okay, one thing. Like this is a, what it is? This is thin convex lens. So this surface is having radius of curvature r1. This is having radius of curvature r2. When you put the values, you have to take with sign convention. R1 is positive because you are measuring in this direction. R1 is positive. When you take R2, it will be negative because that is in the opposite direction. So when you will put the values here, 1 by R1 minus 1 by R2, you will write it like this: 1 by 15 minus 1 by minus 30. Like this you will write. Try to understand this. Is this clear? This is how you have to write it. Okay, why so? You will measure the distance following the sign convention. R1 is on the positive side, R2 is on the negative side. So it will become like this. So it will become 1 by 20 is equals to mu minus 1 into 1 by 15 plus 1 by 30. LCM is 30. It will become 2 plus 1, that is 3. So this becomes 10 here. This is getting cancelled. Mu comes out to be 3 by 2, which is 1.5. So always whenever you use formula, be careful that you take signs properly. Otherwise, if you will be doing 1 by 15 minus 1 by 30, it will be wrong. Next question. A convex lens of refractive index 1.5 and focal length 18 centimeter, okay, in air is immersed in water. The change in focal length of the lens will be. Now it is immersed in water. What will change? You see the formula is 1 by f is equals to mu minus 1 into 1 by r1 minus 1 by r2. R1, R2 will not change. Only the refractive index will change. So for the first case, if I write convex lens of refractive index 1.5. So in air, if I talk about focal length is 18. So 1 by 18 is equals to 1.5 minus 1 is 0.5 into 1 by r1 minus 1 by r2. Next case, now it is dipped in water. So 1 by f dash is equals to refractive index of lens with respect to water. Mu lens with respect to water. What is mu lens? 1.5. What is mu water? 4 by 3. 4 by 3. What it is? This is 4.5. 1.5 into 3 is 4.5 by 4. So 4.5 by 4 minus 1 into 1 by r1 minus 1 by r2. And what it is? 1 by f dash is equals to 4.4 minus 4 it will become 0.5 divided by 4 it will become 1 by 8. So 1 by 8 into 1 by R1 minus 1 by R2. Divide these two equations. Divide these two equations. When you divide it, this part will get cancelled, and f dash by 18 it will become f dash divided by 18 it will become, and here it will become 0.5 into 8, because this is 1 by 8. When you divide it, 8 will go there, it will become 4 here. So f dash is 72 centimeter. What is the change in the focal length? Delta f. Delta f is f dash minus f, 72 minus 18, that is 54. Change is 54. I hope you are able to understand everything. If you have any doubts, make sure to put some comments. And even if you don't have a doubt, you are able to understand, put comment so that we get motivated. Now, lens formula, we already did the derivation for the lens formula. What was that? 1 by V minus 1 by U is equals to 1 by F. Sign convention remains the same. All the distances in the direction of the incident ray are taken as positive, measuring from the optical center. In lens, we take, in lens, okay, wait a minute, we'll come to that anyways. So in lens, this is my optical center. All the distances are measured from the optical center. Any distance in the opposite direction will be negative. Any distance in this direction is positive. The distance upward is positive. The distance downward is negative. So this is the sign convention. Focal length of convex lens, that is positive. Focal length of concave lens is negative. We'll talk about that. Okay, ray diagrams for convex and concave lens. Now, this is the principal axis. So, few of the things to understand how to draw ray diagrams. So, any ray which is coming parallel to the principal axis, like this, it will pass through the focus. Which focus? This focus here. Now there are two surfaces, therefore we have two focus. This we call as F1, this we call as F2. Okay. Second, any ray this is my F1, this is my F2. Okay, so any ray which pass through F1 coming like this will go parallel. Yeah, it will go parallel like this to the principal axis. Next, okay, everything is fine. So, yeah, that's the principal axis. Any ray which is passing straight through the optical center will pass undeviated. Same we can have for convex concave lens also. This was for convex lens. For concave lens, here this is our f2, this is our f1. Okay, so any ray which comes parallel to the focus, parallel to the principal axis, it is coming parallel to the principal axis. Okay, they will in this case appear to pass through f2, not pass through exactly through f2, appear to pass through f2. So if you extend it, it passes like this. Okay, second, if you take any ray which appears to pass through f1, will go parallel, which appears to pass through f1. Okay, so let's take this color, appears to pass through f1, it will go parallel. It appears to pass through f1, and if a ray passes through the optical center, it will go undeviated. Okay, and now here I have homework for you. What is that? Draw all the standard object image ray diagrams for convex and concave lens. And this you have learned in your 10th standard. I'm not doing it here. I hope you are able to understand the fundamental things that I was discussing. Now, power of lens. So, power of lens is defined as the ability of the lens to focus. Okay, so how much the lens is having ability to focus a particular ray. So this we say that as the power of the lens. So it is defined as 1 by the focal length, and the unit of the power is diopter. Which we denote with D. Okay. So and it is meter inverse. Okay, same as meter inverse. So if I ask you, for convex lens the power is positive, for concave lens the power is negative. Convex lens is the converging lens, concave lens is diverging lens. Diverging means opposite of converging, therefore negative power. Okay, so for convex lens, we will say the power is positive. For concave, the power is negative. This is our converging. This is the diverging lens. Okay. Let us do some questions on this. First question. The radius of curvature of each surface of convex lens having refractive index 1.8 is 20 centimeter. The lens is now immersed in the liquid of refractive index 1.5. The ratio of power of the lens in air to that in the liquid is power is 1 by f, and here we will use lens maker formula 1 by f. This is my power. What is this? This is mu relative. Okay, mu relative minus 1 into 1 by r1 minus 1 by r2. Okay, so in first case when you write it, what it will become? This is okay, having refractive index 1.8. so lens is having refractive index 1.8. initially it was in air, so 1.8 minus 1 into 1 by r1 minus 1 by r2. Second case, it is dipped in a liquid and that liquid is having refractive index 1.5. so P2 is equals to 1.8 divided by 1.5 minus 1 into 1 by r1 minus 1 by r2. This becomes my power later. Okay, the ratio of power of lens in air to that in the liquid will be. Now just take the ratio, solve it, and then put your answer in the comments. Pause this video, do it quickly, or I'll wait for 1 minute. Okay, so we got that. We discussed that power is just inverse of the focal length. Oh, here we have RE. So focal length we related in the lens maker formula is 1 by f into mu minus 1 into 1 by r1 minus 1 by r2. That becomes our power. So if focal length is directly given to you, you can directly write power as 1 by f. If the focal length is if let us take the radius of curvature is mentioned, then accordingly you can write it. Okay, now let us discuss this question. The convex lens has power P. It is cut into two halves along its principal axis. Further, one piece in further two halves is cut like this, perpendicular to the principal axis. Choose the incorrect options. Now we need to find the power of each lens. Now what is happening here? If radius of curvature will change, the focal length will change, the power will change. For this lens L1, radius of curvature of both the surfaces is the same as original. So for this I will say power is P only. If this is having power P, this will have power P only. For L1 and L2, radius of curvature one surface is same, another surface is becoming infinite. Plane surface means radius of curvature is infinite. So when you write this formula, 1 by f is equals to mu minus 1 into 1 by r1 minus 1 by r2. This was a convex lens. Okay, yeah, so 1 by r1 minus 1 by r2, my r1 and r2 were, I am considering it will be a equiconvex lens. Okay, so this is having radius r. So for this surface plus r, for another surface minus r. So it is 1 by r plus 1 by r. It was originally. But if you talk about for this lens, so 1 by f dash will be mu minus 1 into 1 by r minus 1 by infinity or plus 1 by infinity, whatever it is. Another surface is flat surface. So here my focal length is getting half. Focal length is getting half. So focal length is getting half means my power is getting doubled. Wait a minute, focal length is getting half or doubled? Here it was 2 by r, here it is 1 by r. So focal length is getting doubled. My f dash is 2f. Focal length is getting doubled. F dash is 2f. So my power is getting half. So here the power will be P by 2 and here also the power is P by 2. Considering this to be equiconvex lens. Okay, power of L1 is P by 2. No, this is incorrect. Power of L2 is P by 2. Yes. Power of L3 is P by 2. Power of L1 is P. Yes. These are correct. A is incorrect. So this is our answer. We need to mark here incorrect option. Yeah. Okay. Now let us discuss about magnification of lens. We had formula of magnification in case of spherical mirror as magnification is equals to minus v by u. Now let us take what is the formula. Let us see for the lens. Now here you may take an object which is kept here. Okay, so let us see how the image will be formed. I'm taking first ray as parallel like this. It will pass through the focus on the other side. This is my focus. Okay, another ray I am considering as passing through the optical center. Okay, so here my final image is formed. General ray diagram I am drawing. Here you may consider, yes. So here my image is formed. Okay. So here I was considered this as my F1. Okay, this is my F2 there. So let us relate the height of image with height of object. So this I am considering as my AB. So this will become my A dash B dash. Okay. Now this angle is theta. So this angle is also theta. Now this, let us take this as my O. Okay. So I can say tan theta in this right angle triangle. Which one? Let me highlight again for you to visualize it. I am talking about this right angle triangle. Okay. So in this right angle triangle, if I write what is my tan theta, so I'll say tan theta is equals to AB divided by B into O. Similarly, on the other right angle triangle here, I'm talking about this right angle triangle now. Okay, so on that right angle triangle, if I write my tan theta, so what that will become? That will become A dash B dash divided by OB dash. Okay, so what is AB? AB is height of object. What is BO? This is distance of the object with a negative sign, so minus U is equals to what is A dash B dash? Minus of height of image. Why negative? Because this is in the downward direction. What is OB dash? That is plus the distance of the image plus V. Okay, so here negative sign is getting cancelled and we got the height of image by height of object is equals to my V divided by U, and this is our magnification. So remember this formula, magnification is equals to plus V by U in case of lens. Okay. Let us do a question. The same size images are formed by a convex lens, okay, it is written again, when the object is placed at 20 centimeter or 10 centimeter from the lens, the focal length of the convex lenses. Now whether you put the object at 10 centimeter or you put the object at 20 centimeter, the size of the image is same. It means if here the magnification if I take as plus M, here the magnification will be minus M. Yes, yes. And magnification we know that is V by U. Okay, this was a convex lens. So V, what we need to find by the way, the focal length we need to find. Okay, so V divided by U, U I can write as minus 10 here. And here let us take this as my V1. Okay, this is my V, which is V2 divided by U is minus 20. So from here I got my V1 to be minus 10M, and from here I got my V2 to be 20M. Now using the lens formula, 1 by V minus 1 by U is equals to 1 by F I'm using. So for this I'll say 1 by V1, okay, here 1 by V1 is 1 by minus 10M minus 1 by u minus 1 by u. What is u? Minus 10 is equals to 1 by f. And same thing here, if I write, it will become 1 by v2. 1 by v2 is 20 m, minus 1 by u2, here it was minus 20, is equals to 1 by f. Okay, so what we will do, we'll equate 1 by 10 m from here and there, and from there we will solve for the focal length. That's all. So 1 by, I'll take this 1 by 10 m on the other side, or let me write it like this, 1 by f minus 1 by 10. So from here 1 by 20 m is equals to 1 by f minus 1 by 20. Okay, so 1 by 10 m, if I write from here, this is minus of 1 by f minus 1 by 10, 1 by 10 m. 1 by 10 m, if I write from here, multiply this with 2, so 2 by f minus 1 by 10. Okay, so this is minus 1 by f. If I take on the other side, this will become 3 by f there, solving it further. So this will become 3 by f on this side is equals to, yeah, 3 by f on that side, and 1 by 10 here it will come, and plus 1 by 10. So this will become 2 by 10. So f comes out to be 30 divided by 2, which is 15 centimeter. I think there is no mistake in calculation. I hope everything is fine. Let me check again. 1 by, yeah, this seems to be fine. Minus, yeah, that is also right. Solving it further, this is 3 by f is equals to 2 by 10. This becomes 30 by 2, which is 15. Okay. Now velocity of image formed by lens. We discussed velocity in case of plane mirror, then we discussed for spherical mirror. Let us talk about of the lens now. Now again, two cases. First, my object is moving along the principal axis with some velocity. Okay, so there I'll relate v and u. So how? 1 by v minus 1 by u is equals to 1 by f. I'll relate it, just a second. Okay. Now differentiate this equation, so this will become minus 1 by v square dv by dt. This differentiation minus minus, it will become plus 1 by u square du by dt. Focal length is constant, differentiation is 0. Okay, from here I can say du by dt is velocity of image, du by dt is velocity of object. So velocity of image is coming out to be what it will become. On the other side, if you take, everything will become plus v square by u square, that is m square into velocity of object. Okay. Now this was for along principal axis. Now I am talking about perpendicular to principal axis. Perpendicular to the principal axis. So this is my lens, and let us take principal axis. This here my object is, let us take, moving somewhat like this. So here you will relate height of object with height of image using the formula. So you'll say height of, formula of magnification. Okay, so you'll say height of image divided by height of object, this is equals to m. Just differentiate it. So dh image divided by dt is equals to m times of dh object by dt. So velocity of image is coming out to be m times of velocity of object. Okay, so this was for along the principal axis. Let us highlight these formulas. This was along the principal axis. This is for perpendicular to the principal axis. Okay, let us do this question. An object is at a distance 20 meter from a convex lens of focal length 0.3 meter. The lens forms the image of the object. If the object moves away from the lens at a speed of 5 meter per second, the speed and direction of the image will be. So this is a convex lens. The object is at a distance of 20 meter. Focal length is given to us as 0.3. The object is moving away from the lens with speed 5 meter per second. Now, first of all, find the position of the image. So 1 by V minus 1 by U is equals to 1 by F. So 1 by V minus 1 by, what is U? U is minus 20, is equals to 1 by F. What is F? 1 by 0.3, that is 10 by 3. So 1 by V is equals to 10 by 3 minus 1 by 20. 10 by 3 minus 1 by 20. Yeah. Okay. Now from here, I got my V. Let me write it again. What it will become? 1 by V is equals to, LCM I'll take as 60. So this will become 10 into 20 is 200 minus 3. So V is equals to 60 divided by 197. Is there any mistake? No. Okay. V I got. From there I'll find magnification. Magnification is V by U. Okay. From there I'll write my velocity of object, because this is motion along the principal axis only. Velocity of object is, velocity of image is equals to m square into velocity of object. Okay. So magnification V by U. V is this. And what is U? U is minus 20. U is minus 20. So 60 divided by minus 20, minus 3 by 197. Okay. So when you write this here, minus m square, so this will come minus 3 by 197 whole square into velocity of object. Object is moving towards the left. What is that? Minus 5 phi cap. Okay. So my image will be moving towards the left and the magnitude is this much. Okay. Moving towards the lens. It is moving towards the lens. So you can calculate it and you can mark which option is the correct. So take a pause, do the calculation quickly and mark it and then come back. Okay. I hope you are back. Now, cutting of the lens. Now, I already discussed for the cutting of the lens thing that when the lens is cut, I took that question first. So when the lens is cut, it can be cut perpendicular or it can be, let us take a, yeah, it can be cut perpendicular to the principal axis or it can be cut along the principal axis like this. So whatever way it is cut, it may have like this, like this, like this, like this, like this. These type of positions it may have. Now accordingly you have to find the where is the distance of the image is there, object is mentioned to you. So what you will do, accordingly you will find first the focal length. How much is the focal length? By using lens maker formula. Okay. The plane surface is having infinite radius of curvature. Spherical surface, curved surface, you already know, the lens is given to you. So accordingly you will find the effective focal length, whatever it is, your focal length, and then you will use in the formulas to find where is the object of, where is the position of the image, or if magnification is asked, you can find the magnification accordingly. We discussed this. Now combination of lenses. Let us take, we have multiple lens. This is one lens. I am taking first multiple lens in contact. This is another lens. Okay, maybe let us take this, may be our another lens. So first of all, I am talking about in contact. If multiple lenses are in contact, this power is P1, this power is P2, this power is P3, my effective power is equals to P1 plus P2 plus P3. Just add all the three powers, because now effectively it will be behaving like one lens. Okay, so total divergence or total convergence power will add up just. So I'll say that 1 by f is equals to 1 by f1 plus 1 by f2 plus 1 by f3, like that. And if they are not in contact, let us take this lens is there, then some distance is there, this lens is there, then some distance is there, another lens is there. In those cases, if you have to analyze, then analyze separately. First, take the object, find the image due to the first lens. Let us take the image as somewhat like this here. Now this image will become object for this. Now take refraction from this lens. Now its image will become object for this. Take the refraction from that lens, and accordingly you can find where is the final image, how much is the total magnification, all those. Magnification, if you talk about, they will like if I ask you, this magnification is M1, this magnification is M2, this magnification is M3. If I ask you how much is the total magnification, that will become M1 into M2 into M3. Why so? So magnification is my height of image divided by height of object. So for the first, if you talk about, this is height of image. For the first lens, if you talk about, it will become height of its first image h1 divided by height of my object. For the second lens, if you talk about its image, let us take this, that is my h2 divided by the height of the object. Its object was that's image, so this was h1 into the magnification of this into, I can say this is my height of the final image, that is my height of image, divided by the object was the image of the first one, divided by h2. Here you see this h2 is getting cancelled, h1 is getting cancelled, you are getting height of image by height of object only. So magnification basically M as M1 into M2 into M3. Power is not P1 plus P2 plus P3 here. Okay, that's not there. If you have to individually find, if you have to analyze, you can say, then you individually find where is the location of the first image, where is the location of the second image, where is the location of the third image, then accordingly you find. Don't try to memorize any effective focal length formula and those kind of things. That is not required for means. Let us do this question. The distance of image from object O formed by combination of lens in the figure. Where is the final image where it is formed? Okay, so due to this lens, the focal length is 10, object distance is 30. Use the lens formula, 1 by V minus 1 by U is equals to 1 by F. So V1, so 1 by V1 minus 1 by, what is U? U is minus 30, so minus 30 is equals to 1 by F. F is plus 10, so 1 by 10. So 1 by V1 is equals to 1 by 10 minus 1 by 30. Is this right? Yes. So from here I can say V1 comes out to be, okay, let us solve it properly only. So this is 30, so this will become 3 minus 1, so 1 by 15. So V1 comes out to be 15 plus 15. So the image will be at 15 centimeter from here. So 15 centimeter from here means, so this is my V1. Okay, this is my V1 here. So this will become object for the second lens. For the second lens, if I ask you where is the image, where is the object, that is at 10 centimeter. At 10 centimeter and the focal length is minus 10. Okay, so it means it is virtual object placed on the, you can say it's F focal length. So where the image will be formed? Infinite. So there now parallel rays will go. Okay, this was a concave lens, therefore I am saying this was a concave lens, and on the other focus it's like this is a concave lens, the rays are coming like this. So effectively they are passing like this. After this, the image, you can say virtual object is there on the focus, the rays will go parallel. So after this, the rays will go parallel. Now these parallel rays are falling on this, where the image will be formed by this convex lens on the focus. So on the focus means here, how much is this? That 30 centimeter. This is 30, so this is 30 centimeter. Okay, so what it is mentioned, find the distance of the image from the object. So 30 plus 5 plus 10 plus 30, 30, 30, 60, 70, 75, 75A. Okay, so at a distance 75 centimeter from the object, my final image is formed. Now combination of lenses and mirror. Now if let us take multiple lenses and multiple mirrors are coming, then accordingly you have to individually see where the first image will be formed by the lens. Okay, if some mirror is coming, now where the image will be formed by the mirror, and if then there again the refraction is happening from the lens, then you have to accordingly see. I am saying multiple lenses and multiple mirrors are there, accordingly you analyze. Now one thing that is frequently asked is, in advance also many times it is asked, that is where the object should be placed such that the final image forms at the object itself. Okay, or sometimes find some distances such that the final image is formed at the object itself. Okay, a mirror is there, final image is formed at the object itself. Now you have to see, final image formed at the object itself means the rays should retrace their path. Now what is the condition for the rays to retrace their path? There may be different conditions. If let us take concave mirror is there, what will be the condition? If in front of the concave mirror, if the image is formed at C, then the object you can say virtual object or whatever is there. I am saying, like, if this is my concave mirror, okay, if you put the object at C, the image will be formed at C. This is one condition. Okay, or if the rays fall like this, okay, then they will retrace their path. Same thing if I talk of convex lens, if the ray appear to pass through C, they will retrace their path. Or if the rays fall like this at the pole, they will retrace their path. Okay, so you have to see which condition is there that is needed to be satisfied for the rays to retrace their path. Now we are having this question here. An object is placed at a distance 12 cm from the convex lens. A convex mirror of focal length 15 cm is placed on the other side of the lens at 8 cm as shown. This focal length is 15 cm. Okay, image of the object coincides with the object. Now image is coinciding with the object. When the convex mirror is removed, a real and inverted image is formed at that position. Okay, the distance of the image from the object will be, okay, this total distance we need to find. He is saying when this mirror is there, the final image is coinciding with the object. If you remove this mirror, this final image is here, find this distance. This he is saying. So I will say that the final image is formed here if the mirror is there. If mirror is not there, the rays are retracing its path. So what is the condition for the rays to retrace their path? One is that they appear to pass through the center of curvature, and where the center of curvature should be? Here. They appear to pass through the center of curvature, then only they will retrace their path. Then only they will retrace their path. Like I should not make the arrows there. Rays are not going. They appear to pass through the center of curvature, they will retrace their path, the image will be formed here back. That is one thing. Okay. Another thing, it could be like the rays falls at pole and then they retrace. That is also possible, but that condition is not happening because the image is forming here. Okay. Therefore, my rays appear to pass through the center of curvature. And if you remove this, the rays will meet at center of curvature. Yes, the rays were appearing to pass through center of curvature. If you remove it, where the rays will meet? Center of curvature. The image will be formed at center of curvature. How much is this distance? Radius. How much is the radius? Twice of the focal length. How much is the focal length? 15. So this is 15 into 2, that is 30. So how much is total distance now? 30 plus 8 plus 12. What is that? 50. Okay. So you have to use logic in these type of questions. Now let us talk about the simple microscope. Oh, we are coming to the optical instruments. So we'll talk about the microscope, then compound microscope, and then telescope. So simple microscope, I'm having a lens. I need a magnified image. I'll put my object between focus and the pole, then only I'll get a magnified image there. Okay, means erect magnified image there. Okay, so if without lens, if I talk about, without lens, if I talk about, the object is here. I'm keeping this object at the near point of the eye. How much is that distance? 25 centimeter, near distance of eye. How much angle this will make at the eye? How much? That is this angle theta object. So I'll say my theta object is equals to height of object divided by this distance d, which is 25 centimeter for normal eye. Okay, now I put a lens. Now certainly I am seeing from here. I have kept a lens, and this is, let us take the distance of the object, and let us take this distance as u. Okay, final image is formed. Let us take the final image is formed at d. Final image is formed at d. Now how much angle is this image making at the eye? That is this angle, theta image. Okay, so that is this angle, theta image. Okay, so that angle you can write two ways, this height divided by this base, or from here also you can write, this is the object, so height of the object, theta image is equals to height of the object divided by this distance u. Okay, theta object divided by this distance u. Now how to relate u? I'll use lens formula. I'll write 1 by v minus 1 by u is equals to 1 by f. 1 by v, v is minus d because that is on that side. What is u? U is the distance, that is minus u. I took this distance as u, so minus u is equals to 1 by f. So here I got 1 by u is equals to 1 by f plus 1 by d. I got my 1 by u, so theta image is coming out to be, what? Height of object into 1 by f plus 1 by d. Now the angular magnification, if I write here, so magnification will become theta image divided by theta object. Theta image is h object into 1 by f plus 1 by d into h naught by d. So this, okay, so divided, it was divided by, so divide, so this will become h naught by d. Everything is fine. This is getting cancelled, so this will become 1 plus d by f. This becomes my magnification, and this magnification is for the condition when final image is formed at d. This is the maximum magnification. Okay, so this is the maximum magnification for the condition when the final image is formed at d. Magnification is there. Okay, but here my eyes are a bit, you can say, strained, or what should I say, there is pressure on the eye. Okay, there is a pressure on the eyes because I have to focus a bit, because if I put some image at near point, so I have to put a bit focus. Now if the final image is formed at infinity, I can very easily see it, relaxed eyes. Okay, so with relaxed eyes, if I want to see, my final image will be formed at infinity. Now if final image formed at infinity, for infinity, this theta image, now I am writing for infinity, for final image at infinity. Okay, let me write it again. For final image at infinity, for final image at infinity, what is my theta I? My object should be at the focus. Okay, so this will become h naught by f. So theta I will become h naught by f. So my magnification will be theta I by theta object. So this is h naught by f. And what is theta object? Theta object is h naught by d. So this magnification is coming out to be d by f. This is for the case when the final image is at infinity. Okay, so this is the infinity case. Let me write image at infinity, and this was image at near point. So if one lens is there, magnification 1 plus d by f. For the case when the image is at d, it will become d by f when the image is at infinity. We will have these two cases only in the questions. Okay, now coming to the compound microscope. In compound microscope, I'm having two lenses. One lens is my object. Okay, so this is my objective lens which is facing the object. Okay, so this is my objective lens. Another is my eyepiece lens. Eyepiece means which is near the eye, from which we are seeing. Here you can say the eyepiece lens is having bigger focal length, objective lens is having lesser focal length, aperture, eyepiece is having greater, objective lens is having lesser aperture. So I put this object here, my first image is formed, I put somewhat near f. Okay, you can say my first image is formed here. Now that image behaves as object and my final image is formed here. Okay, this is my final image. I can consider my final image to be formed at d or formed at infinity. Now if I ask you what is the magnification, you will say the magnification is equals to the product of the two magnifications, magnification of objective into the magnification of eyepiece. What is the magnification of objective? So for lens I can write as v by u, so this is v naught by u naught. For eyepiece, the final image is formed at, if it is formed at d, it will become 1 plus d by f. If it is formed at infinity, it will become d by f. So 1 plus d by f. Let me write this formula a bit down, okay, because I'll write few more things after that. So this is v naught by u naught into 1 plus d by f eyepiece. This is the magnification for image at d. Let me write here at d. Now at infinity, if we talk about, this magnification will become v naught by u naught into this magnification will become just d by fe. Okay. Now generally we set this distance u naught. This is you can say the distance that we choose, our distance u naught, that is choose such a way that this final image, okay, this image is formed, you can say very near to this lens. The image is formed near to this eyepiece lens. So this v naught is nearly equal to the length between this length, we say length of the microscope. This is the distance between the objective lens and my eyepiece lens. So v naught is nearly equal to, I can say, L, not exactly equal to L, nearly equal to L, and my u naught is nearly equal to f, nearly. So for general case, I can write this as f objective, v naught as L. Okay, so this will become L divided by u naught as f objective into 1 plus d by fe, and this will become L into d by f naught fe. Okay, that is nearly. So this is, you can say there is assumption in this formula, but general questions are asked from this. They are talking about, you put these things unless until they specifically mention, talk about the distance of the object and like that, but that is not there in case of mains, that is not there. So generally you need to use this formula. If the image is formed at near point, L by f naught into 1 plus d by fe, and if it is at infinity, LD by f naught fe. F naught was the focal length of the objective lens, Fe was the focal length of the eyepiece lens. Got it? Let us see a question on this. In a compound microscope, the magnified virtual image is formed at distance of 25 centimeter from the eyepiece. Okay, means at D. The focal length of its objective lens is 1 centimeter. If the magnification is 100 and the tube length of the microscope is 20, tube length means L is 20, magnification is 100, okay. The focal length of eyepiece is, now final image is formed at D, so what you will use? 1 plus d by fe into L by f naught. Which formula? This formula. Final image is formed at D, so L by f naught into 1 plus d by fe. Okay, so this becomes my 100. Now put the values. We need to find fe. So 100 is equal, so put everything in centimeter. L is 20, f naught is 1 into 1 plus d is 25. Fe we will find 20 into 5, 5 minus 1, 4, 25 by 4. $6.25. Yeah. Okay, this is 6.25. Now next we are having telescope. In telescope our objective is bigger. Our objective lens is having greater focal length and greater aperture, and my eyepiece is having shorter as compared to the objective ones. Objective is bigger because it want more light to capture, okay, because generally telescope we point at sky, so at night very less light is coming, so we want the objective as bigger as possible so that more light is coming. More light is coming means a better clarity of image will be there. So light are coming from infinity, parallel rays will come, parallel rays are coming, image will be at focus. This image will behave like an object for the eyepiece, and my final image is formed at D or at infinity. Now if I ask you the magnification here, magnification will say the angle formed by the object, that is this angle alpha, and the image, that is this angle beta, okay, which is nearly equal to this angle beta. So magnification is beta by alpha. Now two cases. First, image at infinity, okay. So first case at infinity. So image formed at infinity. So if the image is formed at infinity, this is f naught, image is formed at infinity, it means this also has to be equal to the focal length. This is eyepiece focal length, this is my f objective, this is my objective lens, okay, towards the object, and this is my eyepiece lens. Okay, so here its focal length is f naught, this focal length is eyepiece objective lens, eyepiece lens. Okay, now if I write alpha, alpha is my a dash b dash divided by f naught, and beta is a dash b dash divided by fe. So a dash b dash divided by fe into Alpha was A dash B dash by F naught. A dash B dash divided by F naught. A dash B dash got cancelled. So this is F naught by Fe. So this is the formula for magnification when image is formed at infinity, F naught by Fe. In telescope they will ask this only. Okay. Now second case, when the image is formed at D. Rays are parallel, first image will be at here only. Now second case, when the image is formed at D, this distance will be somewhat different. Let us take this as UE. For this lens, for eyepiece I am using the formula 1 by V minus 1 by U is equals to 1 by F eyepiece. So 1 by V, V is minus D, V is minus D. What is U? I need to find, okay, I need to find, so minus 1 by U. Let us take this distance to be U, okay, so minus U of this with a sign is equals to 1 by F eyepiece. So 1 by U comes out to be 1 by F eyepiece plus 1 by D. So when I write my beta in this case, okay, for second case I am talking about. This was image at infinity. Let me write, okay, let me take this hole in one box. Okay, now I am talking about image at D. Image at D, so M is equals to my beta by alpha, same thing. Let me write beta first. What is beta? Beta is this angle beta, okay, that is my A dash B dash divided by U. So that is A dash B dash divided by U. So this is A dash B dash into 1 by U is 1 by Fe plus 1 by D. 1 by Fe plus 1 by D. This is beta divided by alpha. So by alpha. What is alpha? Alpha is same thing. A dash B dash divided by F naught. So A dash B dash divided by F naught. So here A dash B dash divided by F naught. A dash B dash is getting cancelled. So this becomes F naught into 1 by Fe plus 1 by D, and this becomes my magnification. Okay. So this hole is for the case when the final image is formed at D. In telescope, they'll ask this formula, first one, in mains. Second one I wrote because in microscope also we are writing the two conditions. So here also we wrote the two conditions, but if in telescope a question comes, it will be from here. Let us do this question. In normal adjustment for a reflecting telescope, the distance between objective and eyepiece is 30. So objective and eyepiece is 30. In normal adjustment, what is that distance? F naught, and this was also equal to the focal length Fe. So this distance is at normal adjustment, this is F naught plus Fe. At normal. Normal means image at infinity. Normal means image at infinity. At infinity. Normal means image at infinity. So F naught plus Fe 30 centimeter. The focal length of the objective when angular magnification of the telescope is 2. 2 is given as F naught by Fe. This is this. This is this. Now what I need? The focal length of the objective. I need F objective. So F eyepiece is F objective by 2. Put it there. So F objective plus F objective by 2. This is 30 centimeter. Okay. Yeah. So 3 by 2. F objective is 30. This is 10. F objective comes out to be 20 centimeter, which is option A. Okay, 20 centimeter. So this was a long discussion, I'll say, and this ray optics chapter is important. As I already mentioned, the weightage in mains is great, as well as in advance the weightage is also great, and many of the things which I have discussed in great detail. I have done all the derivations that are required. I didn't skip the derivation also. So I did all the derivation. I showed you the different types of questions that are asked in mains, from which topic the questions are asked, from which topic the questions are not asked. I mentioned all those things. Okay, so I hope this particular discussion will really help you, and make sure you do some question practice also from the sheet that is given in the description. Okay, so in the description, go to the link. From that link you'll join the free batch on our PW app. From there you can download the class notes, that what I have discussed here you'll get there, as well as the practice sheets. So make sure you solve questions from the practice sheets. Thank you all. Meet in the next video, and hit the like button if this video really helped you, and leave a comment that you completed this video. Thank you. Have a nice day.